Hello guys, welcome to this tutorial. I am Manoj. I create contents for developers. Subscribe to my channel and press the bell icon to get the latest updates from this channel. In this course, we are going to discuss about some basic concepts like IDEs, SDKs and runtime. After that, we are going to have a look at how the code is physically and logically organized using projects, solutions, namespaces and classes. Then we will discuss more about data types and variables. After these basic concepts are covered, we will discuss about some programming constructs that are used in almost every program. And those constructs include conditions, loops, jumps, strings, arithmetic operators, arrays, and collections. I am going to use only built-in data types to make sure that the discussion is simple and easy to understand. Now let's have a look at how the chapters are designed. Every chapter will begin with some theory part. After the theory part, there will be a code along session in which you can try to code with me on certain problem statements. And at the end of every chapter, there will be some exercises that you can try on your own. I believe that this structure is going to help you to get most out of this course. Let's get started.
Learning a new programming language or framework is generally a three-step process. First of all, I should understand when experts talk about it. Secondly, I should also be equipped with same vocabulary so that I can talk the same language. And third one, of course, I should be able to write the code using that programming language. In this course, every chapter will start with explaining few jargons, which will help us to cover first 2 points, understanding and talking the same language. Then the chapter will drill down further to explain the C# syntax and technical concepts which will enable you to write the code. So without further delay, let's dive into today's topic. So today we are looking at most important concepts, runtime, SDK and IDEs. Let's start with IDE. It stands for Integrated Development Environment. It is a software which developers use to type the code. Ideally, you can also use any simple text editor for writing the code. You can type C# code in, let's say, Notepad, the most basic text editor provided on Windows PC. But IDEs provide some additional features to boost developer productivity, and that's why most of the developers prefer IDEs. Some famous IDEs used for .NET development are Visual Studio Code, and Jetpens Rider. This C# code that you typed using IDE needs to be converted into a low-level code which the processor can understand. For that conversion, some tools are provided by .NET. The converted code is stored in a file which may have either .dll or .exe as an extension. A DLL or an exe is also called an assembly. The .NET runtime can read these assemblies and execute the code. You can think of runtime as some kind of virtual box which has responsibility to run the .NET assemblies. If your machine doesn't have .NET runtime, then it will not be able to run .NET programs. So, an IDE is to write the code and runtime is to run the compiled code. Then what is SDK? SDK stands for Software Development Kit. It includes runtime as well as some other tools which help developers. To further understand these concepts, let's take an example. Let's say you want to develop a Notepad-like application using C# and .NET. So you will need to install an IDE and SDK on your development machine. Once your development is complete, you will somehow distribute your application to its end users. Those users do not need SDKs on their machine. They would just need to have a .NET runtime installed on their machine to use your Notepad. I hope these 3 concepts are clear now, and you should be able to use these 3 words, IDEs, runtime and SDK, in the conversations. Now let's quickly have a look at how to install runtime or SDK. For installing runtime or SDK, you can go to .NET website from your browser, literally dot.net. Once you reach there, it will show you a list of all .NET versions available. For every version, it will also show a download link for runtime installer and another link for SDK installer download. But we are not going to download runtime or SDK for now. Why? Because while installing IDEs, the installer will also install SDKs. SDKs also contain runtime. So if you want to set up a development machine just installing an IDE is sufficient. As I mentioned earlier, Visual Studio, Visual Studio Code, and Jetpens Rider are some of the famous IDEs. You can use any one of these IDEs to get started. Let's have a look at how to install these IDEs. Visual Studio is the IDE provided by Microsoft. It has different editions. Enterprise Edition, which is a paid version, Professional Edition, which is also a paid version, and Community Edition, which is free for everyone. Installing any of these editions will involve same steps. Let's check how to install Community Edition. So now let's go to visualstudio.microsoft.com and then select Community Edition to download the installer. Once the installer is downloaded, we can start the installation. The installer would show a Workloads tab by default, and there we can select the features that we want to enable in the IDE. The tab shows a lot of features, and that's why it may be very confusing for beginners. I would suggest to select ASP.NET and Web Development, Azure Development, Node.js Development, and .NET Desktop Development features from this tab. You can also select other features like Python development or let's say mobile app development if you need them. This feature selection would decide which SDKs Visual Studio should install. Optionally, you can also select individual components and SDKs on the second tab. As you can see, you can select various runtimes and SDKs that you want to install. You can choose to have multiple .NET versions on your development machine. On the next tab, you can select the language packs. This option is useful if you want to see the Visual Studio menus and options in any language apart from English. I would just leave the default selection. On the last tab, you can select the installation directory. It is the directory where the Visual Studio would be installed. It also allows you to select the download location where all the selected installers would be downloaded in the process. Again, I would leave these settings to the default. Near the install button, it provides a drop-down where you can set if you want to continue the installation and downloads in parallel. This is the default selected item. I would just leave it to the default and click on install. The installation may take several minutes to complete. I would suggest you to use Visual Studio Community Edition because of two reasons. First of all, it is free, and secondly, it would be easier to follow my instructions as I also use Visual Studio. Okay, let's move on to the next option. Second option is Visual Studio Code. It is a cross-platform, lightweight, and free IDE from Microsoft. Navigate to visualstudio.microsoft.com and then under Visual Studio Code, select the appropriate option. Alternatively, you can go to code.visualstudio.com/download. There are three options for Windows: User Installer, System Installer, and a zip package. The user installer would install Visual Studio Code only for current user, while System Installer would install Visual Studio Code for the whole system. This means all the users who log into the system can use Visual Studio Code if System Installer is used. I am going to select System Installer for download, and once the installer download is complete, you will just need to click through the wizard to start the installation. Once it is installed, you can open Visual Studio Code and then install OmniSharp extension. It would help you to run and debug the C# code. Okay, let's move to the third option. Jetpens Rider is another popular IDE. Sadly, it is not a free tool. You will need to purchase a license if you want to use it. It provides a 30-day trial period, so if you want to give it a try, you can go to jetpens.com/rider, where you will see the download link. Then you can download it. Once the download is complete, you can run the installer. I personally feel that its installation is a bit easier than Visual Studio's installation. You just need to click through the wizard and it would install it. So now let's have a look at the next and the final option in the list. If you are not yet ready to install any IDE on your machine, then you can also use online tool to learn C#. You can search for .NET Fiddle and then open this site. It provides options to write a basic C# code. You can also run the code there and check the output. If you want, it also provides options to add references to the NuGet packages. This may be useful to learn the C# syntax, but I would strongly recommend to download Visual Studio IDE to follow this tutorial. Also, if you use an IDE, you can learn some more things like how to navigate through the code and how to organize the code, etc. All these things you cannot really learn with .NET Fiddle. So that's it. These are the 4 options that I wanted to present. You can use any of them to get started with C# and .NET. Again, if you use Visual Studio, it would be easier to follow the instruction provided in this course. Let's get started. Let's open the Visual Studio. On the right side, select an option to create a new project. Once you select it, it would show a new panel. This new panel shows a search box at the top. It also shows 3 drop-downs to select a language, a platform, and a project type. In all these 3 drop-downs, the default option selected is all, which means do not filter anything and show all the available templates. Although we can directly search for console in the top search box, we are not going to do that. Let's try to filter the list of templates by using the drop-downs. The first drop-down is for language. .NET supports multiple languages. As this is a C# tutorial, we are going to set language to C#. Still, there are many templates in the list. So let's move to the second drop-down. Second drop-down is for platform filter. We can run .NET based code on variety of platforms like Xbox, Azure, Windows, Linux, etc. For now, let's set platform to Windows. If you are using Linux or Mac OS, you can also select that as a platform. The third drop-down is for project type. This is decided based on what kind of project you want to develop. There are various options. You may want to create a phone application for Android platform, or you just want to create a web application, or let's say you just want to create a unit test project. You can select the appropriate project type in this drop-down. For this chapter, we are going to select project type console. This is because console application template contains least amount of pre-written C# code. It contains a single statement to print hello world. If you have set platform to Windows, then selecting project type to console would show you 2 project templates. The first project template console app is for .NET Core, now known as .NET, and the second project template is for creating console application using .NET Framework. The console application using .NET Framework template is targeted to use .NET Framework, which is older implementation of .NET. The .NET Framework was targeted only to Windows. That's why you cannot see Linux and Mac OS as tags on that project template. If you select this project template, the console application would be able to run only on Windows platform. For this chapter, we are not going to use .NET Framework. We are going to use the latest .NET 6, and that's why let's select the first project template and then click on Next. On the next screen, the wizard panel would ask for some more inputs. Firstly, you can set the project name. Then you can set the location where this project should be created. By default, it would show you some location. You can change that location by clicking on the browse button and selecting the appropriate location. The third input box is for providing a solution name. By default, this is populated with the same text that you have entered in the project name text box. Let's change the name to something else. And the last input is the checkbox, which decides whether to create a separate directory for the project. Let's talk more about what is the difference between project and solution and what these inputs mean. A project is a construct to group a set of logically related files. You write the code in C# files, and those files can be organized into various folders, and all those logically related folders and files can be placed into a single project. When you create a C# project, it creates a text-based file with .csproj extension. The name of this file is same as the name that you have given to the project. Also, a new directory with the same name is created, and the csproj file is placed inside that new directory. When you work on the bigger projects, you may need to create more than one project for a single application. All such logically related projects are grouped together using a solution file. A solution file is also a text-based file with .sln extension. The directory in which sln file is created is called as solution directory. Inside the solution directory, there might be multiple project directories. Each project directory
contains a single project which is part of that solution. This whole structure is analogous to a tree. Every tree has a big trunk which holds all the branches together. Likewise, every solution has responsibility to hold all the logically related projects together. And every branch on the tree has multiple small branches and leaves. Likewise, a project can contain multiple folders and files. Okay, this is how solution and projects are related. Now let's come back to the new project wizard. I think the purpose of first 3 inputs should be clear now. Let's talk about the 4th input, which is a checkbox. Sometimes you may not want to have a separate child directory inside the solution directory, maybe because the project is small. In that case, you can select the checkbox to place the project and solution both in the same directory. That means csproj file and .sln files will be created in the same directory. But in most of the cases, it is better not to select this checkbox. This means it is better to let the project be created in its own directory. So for now, we are not going to set this checkbox option and we are going to click on next. On the next panel, there is a single input to select the target framework. It shows multiple .NET versions inside a drop-down. Before we understand what it is, let me tell you one more thing about the project. Every project contains multiple folders and files. And when we compile all those files, .NET produces a single file with .dll or .exe extension after compilation is done. This .dll or .exe file is supposed to contain compiled version of all the code which is part of that particular project. For compilation, we will need compilers, and compilers are part of SDKs. Also, as stated in the previous chapter, we can install multiple versions of .NET on development machine. If you have multiple versions of SDKs, you will also have multiple versions of compilers. Then how will you decide which version of compiler should be used to produce a .dll or .exe from your project? This decision of selecting appropriate version for a project is taken based on a setting which is stored inside a csproj file. Every project has a csproj file, and every csproj file contains a setting called as target framework. This setting is read by .NET while compiling the project to decide which version of compiler should be used. This target framework can be set from this screen of the wizard. Let's select .NET 6 here and then click on create. This should create a new project for us. Yay! So we just created our first project. I tried to explain each and every input that is required to create a new project and a new solution. That's why it took longer for us. But as we know the concepts now, creating a new project should be very quick task. Okay, let's see a few more things in Visual Studio. This panel on the right hand side is called as Solution Explorer. It shows all the files, folders and projects which are part of the solution that we have opened. Currently, our solution contains a single project, project_2, and this project has a single C# code file, program.cs. If we open this file contains a single line of code. It tries to print the text hello world on the console. The method console.writeLine is used to print the text on the console. Please note that the text that we want to print needs to be inside the double quotes. Now, let's open the solution directory on file system to see how the folders are created there. For this, we need to right click on the solution. This will open a context menu and then select open folder in file explorer from the menu. In the file explorer, we can see that a solution directory is created. A project directory is created inside the solution directory. Project directory contains a csproj file and a program.cs file. In addition to these two files, project directory also contains two other folders. One folder with name obj and the other folder with name bin. Bin directory contains output of the compilation of the project, that is the .dll or .exe package generated from the compilation. The obj folder is used as an intermediate folder by the compiler while packaging your code into a DLL or an exe. Now let's go back to Visual Studio and let's try to run the code from our project. We need to click on this dark green arrow to run the project. Once this arrow is clicked, Visual Studio starts building the code. This build triggers the compiler, and compiler converts the code inside our project into a .exe. If the compilation is successful, it would open a new console window and it will show the output, and that's it. we can see that the output is printed on the console. Before we close, I want to show you one final thing, project settings. For opening project settings, we can right click on the project and select properties from the context menu. Once it is open, we can see that output type has been set to console application as we created the project of type console app. Also, the target framework has been set to .NET 6 because we selected .NET 6 target while creating the project. In the last chapter, we created a new console app and saw that program.cs file had a single line of code to print the hello world. This statement was not inside any class or any method, and that's why this kind of statements are called as top level statements. If you already know some programming languages like C or C++ or Java, you already must know that all the execution of the program starts with a method called as main, and that's why you may also have an obvious question, where is main method here? How the code execution is beginning. Also, this code may give a wrong impression that C# code is like a script, and that's why C# code doesn't require main method like some other scripts. But this assumption is not correct. Let's see why this assumption is wrong. If you set language version to C#8, the console app comes with the default code as shown here. The code contains some keywords that we have not covered yet in our course. But in short, this code tells compiler that a new class with name program is created within the namespace hello world. This class has the main method. The main method uses a console class from the system namespace. The main method calls a writeLine method from the console class to print the text. Okay, this is nice, but it contains some ceremonial code like declaring namespace, declaring a new class, and declaring the main method. So C#9 introduced a new feature called as top level statements. With C#9, you can avoid having a main method. You are still required to specify the using statements at the top, and after that you could directly write your code. With latest .NET 6 and C#10, one more feature is introduced, and its name is Implicit Usings. You do not even need to specify a using statement and still your code would work. How is this whole thing working now without main method? The feature Implicit Usings is just helping you to save some keystrokes. Although using statements are not present in our C# file, they are available in compiled code. The using statements are getting auto-generated during the compilation. Later in this course, we will see how they are auto-generated. Okay, similarly, the compiler also generates an implicit main method to serve as program entry point for the project with top level statement. When you run the program, runtime finds this auto-generated implicit main method and invokes it, and that's how the whole thing works. Bottom line, ultimately the compiled code contains namespaces and the main method, and that's the reason I think this is the right time to get ourselves introduced to the concept of namespaces. To understand the concept of namespaces further, I will create a new console application project. I will delete all the code inside program.cs file, and then I will add another version of the same code with namespace and main method. Okay, this is ready now. In object-oriented programming languages, class is used to model real-world objects. And like main method here, a class can contain few methods to process few things. For example, there may be a file class which contains method to read and write the files from file system. And the console class that we are using in this example contains methods to write text to the console. In fact, the .NET provides many libraries which contain ready-to-use code for performing operations like making HTTP call or reading file or making calls to databases, etc. All these libraries contain huge number of classes. The namespaces provides a way to attach a contextual meaning to these classes. For example, there is a namespace system.io that contains all the classes related to input and output operations. Another namespace system.data.sql client contains all the classes which can be used for accessing data from SQL Server. You can think of a namespace as a virtual organizer. It helps you to organize your types into different compartments. Those compartments are logical. When you define any interface or class or struct, it would be part of a namespace. For example, here in this project, we can write a new class inside the current namespace. Let's say it has two methods, add and subtract. Currently, those methods just print the method name, and that's how the code will look like. Okay, next point,
A namespace can be nested inside other namespace. Such a nested namespaces are delimited by the dot character. There are two ways to nest a namespace. First way is to define the child namespace inside another namespace. For example, in this project, we can declare a new namespace math inside the namespace C#.tutorial and move the class calculator inside it. The calculator class is now part of C#.tutorial.math namespace, and fully qualified name for the calculator class is C#.tutorial.math.calculator. Second way for nesting namespace is directly defining the namespace with the full name. That way, the nested namespaces can also exist in different C# files. For example, I will now create a new namespace with the name C#.tutorial.posts, which contains a class with name postService, and the class has two methods, add and update. The fully qualified name for this class is C#.tutorial.posts.postService. Namespaces also help in avoiding class name collisions. Now, what is a name collision? Let's take an example of files and directories. Let's say there is a folder and it contains a file with the name file.txt. You cannot create another file with the same name. It is simply not allowed by the operating system. This is called as name collision. This is how the name collision is avoided on the file system. Two files cannot have same paths. Namespaces serve similar purpose. A namespace cannot contain two classes with the same name. That's a rule. That's like a resolution to the name collision issue. So let's go back to Visual Studio now and let's try to create a class with same name as calculator in the namespace C#.tutorial.math. This red squiggly line is telling that there is an error. If I hover over this line, it tells me that the namespace already contains class with the same name. So a namespace cannot contain two classes with the same name, and that's how the name collision is avoided. Okay, we discussed enough about namespaces. Now the next question, why do we need using statements? So every type which is declared in a namespace has a fully qualified name. Namespace name dot type name. So the fully qualified name for console is system.console. As I explained earlier, implicit using feature is auto-generating the using statements, and it is by default enabled when we create a .NET 6 project. So let's disable implicit using feature on our project. To do that, right click on the project and then select properties option from the menu, then search for implicit and then uncheck this checkbox and then hit on save. Now let's come back to our program.cs file. Let's remove the using statement at the top and try to build the solution. Well, even before building the solution, we got errors. The errors are saying that the console class is not present in the current context. It is not identified. Technically, we can use its fully qualified name every time we use this class. So I can just go ahead and I can type fully qualified name system.console every time we need to call write line method. But typing the namespace again and again is really time consuming. That's why we need a using statement at the top of the file. The using statement is a directive for the compiler. This directive is used to tell the compiler where it can look for the classes. You can specify a statement using system at the top, and then you can use any type which is declared inside that namespace without having to specify fully qualified name. The point to note here is if you want to use types from any other namespace, you just need to add a using statement at the top. You can type it manually, or alternatively,
if we hover over the class name, we get a bulb icon. If we click on it, the first option from the context menu is to add a using statement automatically at the top of the file.
For example, there is an option to add using statement at the top. If I click it, using statement will be added. Now, next question. How should we decide what should be the namespace for our code? Generally, your namespace should begin with company name followed by application name. Let's say our company name is Contoso and we are creating an application with name CRM. The namespace for our code base may start with contoso.crm. You can also add any other token if you want. For example, you can add module name and layer name after the application name to distinguish the classes logically by module as well as by application layers. As long as it is logically organizing the code, it is fine. Now let's come back to Visual Studio. Every project has a default namespace setting in the CSproj file. Whenever you add a new class in your project, that class picks the namespace name from this setting. You can always change either the setting from CSproj file. On the other hand, if you want your class not to be part of the default namespace, then you can just change the namespace declaration in the new C# code file that you created. Also, generally, many solutions prefer to have default namespace for a project to be same as project name. For example, if your project name is contoso.crm.dataaccess, then the default namespace for that project would be contoso.crm.dataaccess. Sometimes the other option is people just drop company name and application name from the project name, but the default name still contains it. For example, the project name might be data access, but the default namespace for the project would be contoso.crm.dataaccess. For your information, all the namespaces that begin with system are for the code that is provided as a part of .NET itself. Microsoft also releases some packages which are not part of .NET framework. They are like an extension to the .NET framework. For example, Microsoft releases a package for Entity Framework Core, which is used to access the data from database, and the namespace for the code inside that package is Microsoft.Entity Framework Core. I hope the concept of namespace is clear now. Let's first understand why do we need variables. Any software program is basically a collection of step-by-step instructions. Each instruction performs some operation on input values. Some instructions may produce intermediate values, and then there are some other instructions which perform some other operations on intermediate values, and ultimately this step-by-step execution produces the desired outcome. All the inputs and intermediate values are stored in the computer memory. The instructions in your program are supposed to access this data. One way to access the data is program should always know the exact memory addresses of each and every value that is required for processing. Even if we think that this may be possible, there are few problems. If we run the same program multiple times on the same machine, there is no guarantee that the memory addresses allocated for the program would be same. Also, the memory addresses available on one computer may differ from those on other computer. One computer may have more memory while the other computer may have lesser memory. Just to give you idea about how difficult it would be to handle memory addresses, let's take a real world example. Every place on the earth can be identified by using latitudes and longitudes. But it would not be very easy to understand if someone uses those values in our day-to-day conversations. Likewise, it would be very difficult and time-consuming to program if you want to handle actual memory addresses in your code. That's where the concept of variables comes handy. A variable allows you to access the data stored in the memory. The program then doesn't need to worry about memory allocations and addresses. Compilers and runtime will take care of handling all those low-level tasks. Our code can just declare the variables with appropriate name and then use those variables wherever required. Note that variables must be declared before using them. Let's say we are working on a calculator application. The calculator allows to perform any one of the 4 mathematical operations which are add, subtract, multiply and divide. Let's say application asks user to enter 2 numbers and then user can also select the operation that should be performed. So inside our code we can declare 2 variables, one for each user input, and then those 2 variables can be used for performing mathematical operation.
Now let's see how to declare a variable. Generally, a variable declaration in C# starts with a data type followed by the name of variable. The name of variable can contain letters, digits or underscores. A variable name can start with either a letter or an underscore. Okay, let's move to data type now. A data type basically decides what kind of values can be stored in the variable. For example, there are few data types which allow only numbers to be stored. Data type also sometimes decides minimum and maximum values allowed in the numeric variables. Data type also decides whether a single value of the given type is allowed or whether the variable can also store multiple values of the given type. Compilers must always know the data type during the compilation. C# is a strongly typed language. Now what is the meaning of strongly typed language? Every variable must have type. Also, this data type cannot change during runtime. If you try to assign the values which are not allowed, then the program will get compilation errors. Compiler would fail to compile the program. For example, if you declare a variable to be numeric, then you cannot assign a Boolean value true or false to it. Compiler will throw errors saying that this is not allowed. We have seen how to declare a variable. Now, one more concept before we dive into the code. C# provides a lot of built-in data types. You can define variables to hold the numbers, alphabets, or sequence of alphabets, etc. In addition to built-in data types, C# also provides a way to create your own data type by using structures, classes, and records. In this chapter, we are going to cover only built-in data types. We will cover structures, classes, and records in some future chapters. There are 2 more concepts that we all should know. All the data types in C# can be broadly classified classified into two categories: value types and reference types. Let's start with value types. A value type variable is a variable which directly holds the values at the assigned memory location. A value type also has one characteristic. Regardless of the value it contains, a value type always takes fixed number of bytes in memory. For example, a numeric data type integer will always take 4 bytes in C#. A character data type would always take 2 bytes. When the variables are allocated in memory, there is one more important thing. The program memory is generally divided into two main areas: stack and heap. The value types are stored on stack. Some very common value types are integer, long, character, and boolean. Okay, now let's look at the reference types. A reference type variable does not directly store the value, but it stores the reference to the memory location where the actual value is present. So the reference type variable is like a pointer. Another characteristic of a reference type variable is its size generally is not fixed. The actual size depends on how much data is present. For example, the string hello world would need lesser memory space than, let's say, hello world again, as it contains less number of characters. Also, the reference type values are stored on heap. As the diagram shows, the actual object is created inside the heap. The reference to that object is on the stack. So the program needs to make an additional jump to another location inside heap to read its value. Some very common reference types are string and object. We can also define our own reference types by using the keyword class. Since we are talking about the reference types, let's also talk about a special value, null. A null is a special value for all the reference type variables, and it means that the reference type variable is not pointing to any value. Null can be assigned to reference type variables, but null cannot be assigned to the value types. Okay, we have discussed enough about data types and variables. It's time now to get our hands dirty and declare some variables in the code. Let's open the Visual Studio. Let's create a new console application. The .NET 6 console application template does not contain main method, but as we are learning C#, my recommendation is to keep everything explicit so that we understand each and every bit of what is happening. So I am going to disable the implicit usings. Then I am deleting the default code from program.cs. And now let's add the main method which prints hello world. Okay, we are there. Now we will try to declare variables in code. We will also try to cover some basic operations allowed for each data type. Let's start with string. String is a reference type. Anything inside double quotes can be considered as a string. For example, in our program, we can create a new variable to hold the string hello world. The equal to sign here is called as assignment operator. The variable which you want to initialize should be on the left side of this equal to sign. The value that we want to assign should be on the right side of this assignment operator. Okay, the variable is declared now, and we can use this variable inside console.writeLine to print the value. A string can contain each and every character, including brackets, hyphens, currency symbols, digits, and even quotes. For example, here we declare another string variable which contains all the special characters, including curly brackets, square brackets, hyphens, plus operator, everything. Double quotes mark start and end of a string. So if you want to include a double quote inside a string, then you need to escape it with a backslash. Let's create a variable which contains a double quotes. Note that backslash is not going to be part of the string. Also, string variable may contain only digits, but that does not mean that you can perform mathematical operations on that string variable. If the digits are inside double quotes, they are considered to be text, and mathematical operations are only allowed on numeric data types. One more thing, a string can also be an empty string. It may not contain any character, simply starting double quote and ending double quotes, or you can use string.empty. Note that C# considers white space as a character. So if you declare a string which contains white space, it is not considered as empty string. Every time you change the value of a string variable, a new object is getting created on the heap, and the reference to that object is stored in the string variable. The number of bytes taken by string depends on the number of characters present in the string. Every character takes 2 bytes in .NET. So total bytes occupied by the string is equal to 2 multiplied by the length of that string. You can get the length of any string by using .length property. Common operation for string is concatenation. It's easy. Just use a plus operator. It will combine the two strings into one. And after using plus operator, do not forget to use assignment operator to store the combined value. As this is the only reference type that we are going to cover today, let's try to assign null to a string. we can just create a new variable of type string and then initialize it with null, like this. Note that this produces a warning, but currently we are going to ignore it. Also, some variables are grayed out because we just have declared them, but we are not using them for any operation. For each such variable, a warning is generated by compiler, suggesting either to use the variable or to remove it completely. This warning makes sense, but as this chapter is only about declaring variables, we are going to ignore this warning. Okay, let's move on to the next type. Let's look at the character type now. It is a value type. In computer world, characters are internally integers. You might have seen ASCII map of characters where each number actually maps to some character. In .NET, Unicode characters are supported. This means that a character is internally 16-bit integer value, and every integer value represents a single character from Unicode character set. A character value should always be inside single quotes. Note that it is a value type and hence we cannot assign null to it. Note that empty values are also not supported for characters. You must specify a character within single quotes. Also, unlike string, plus operator would not combine two characters. It would perform addition of the two integer values. Let's move on to the next type. Next, we are going to have a look at Boolean data type. It is the simplest value type. If you declare a variable of type Boolean, its value can either be true or false. C# provides bool keyword for Boolean type. True and false are also C# keywords. They can be used to set the Boolean type value. Generally, every C# keyword is highlighted in blue. In C#, a keyword is a word that carries some special meaning. For example, bool is a keyword that is used to declare variables of Boolean type. String is a keyword which is used to define variables of string type. True and false are also keywords which can be used to specify values. Common operation on Boolean type is negation. The exclamation mark negates a Boolean value. For example, let's declare a variable of type Boolean. Its name is product free, which is to tell whether the product is free or not. And let's say we also declare another Boolean variable has price, which needs to be true if the product is not free. In that case, we can simply use negation, that is the exclamation mark followed by is product free, the variable. Even if we do not assign any value to a variable, the variable gets initialized with some default values. If you want to check the default value of a data type, you can use the default keyword. For example, let's check what is the default value of Boolean type. So if I declare a new variable and initialize it with default of bool, and if I run the application, then I can see that the default value of Boolean is false. Okay, let's move on to the next type. Okay, let's talk about numeric types. Numeric types can be broadly classified into two areas: the types which supports number with decimal points and the type which does not support decimal point numbers. Let's start with the types which do not support decimal point numbers. There are four such types: sbyte, short, int, and long. Sbyte occupies 1 byte in the memory, short occupies 2 bytes, int occupies 4 bytes, and long occupies 8 bytes. More the number of bytes, more is the range of possible values which can be assigned to the numeric type. You can find minimum and maximum possible value of any of these types by using max value and min value properties. For example, let's declare a variable of type long, and to check what is the maximum possible value for this variable, we can print long.maxValue. Similarly, for knowing the minimum value for long, we can try to print long.minValue. These four types support negative numbers as well as positive numbers. If your input area does not include negative numbers, then you can also choose unsigned types. These unsigned types do not support negative numbers, and those types are byte, ushort, uint, ulong. The first letter U stands for unsigned. Now let's talk about the numbers with decimal points. There are three data types that are provided by C#: float, double, and decimal. Float occupies 4 bytes, double occupies 8 bytes, and decimal occupies 16 bytes. These three types differ only in the precision they offer. Precision means how many digits after decimal points can be stored without automatically rounding the number. Float offers precision of approximately 7 digits after the decimal point. Double offers precision of around 15 digits after decimal point. Decimal data type offers highest precision of around 29 digits. If you want to initialize a variable of float type, then the value should be suffixed with letter F as shown here. If you want to initialize a variable of double type, then no suffix is required. And for initializing value of decimal type, the number should be suffixed with letter M. Generally, decimal type should be used where highest accuracy is required. For example, financial calculations need exact accuracy. Even small rounding may cause errors in the calculations. Minimizing memory requirements for a program may be one of the reasons of choosing double and float over decimal. Also, you can use double when optimization for performance is more important than accuracy. Now, as we know, numeric types support mathematical operations, and common mathematical operations that are supported by numeric types are addition, subtraction, multiplication, and division. For addition, we can use plus character for adding two numbers. For subtraction, we can use hyphen, that is minus sign. For multiplication, we can use asterisk, and for division, we can use a backslash. If all the numbers involved in a mathematical operation share the same type, then the result would also have the same data type. If the numbers involved in a mathematical operation have different types, then the result will have type of an input which had a larger size. For example, addition of int and long type variable would return a result of type long. If one of the input in mathematical operation is a number with decimal points, then the number with decimal point would be returned. For example, addition of int and double would return a double. Okay, let's move on. Till now, we have covered string, character, boolean, and numeric types. Now let's have a look at how to handle date and time values. C# provides a type datetime, which is a struct. A struct is always treated as a value type, and hence datetime is also a value type. You cannot assign null to a datetime variable. As the name suggests, a variable of this type contains both date and time values of a moment. For example, we can declare a datetime variable and we can initialize it with datetime.now. Datetime.now provides the value of today's date and current local time, the time at which this line of code was executed. Datetime.utcnow provides current UTC date and time. You can also declare a datetime variable using specific date and time values. For example, we can create a new variable of type datetime and then specify a new keyword followed by the name of type, and then in brackets we can specify three numbers for year, month, and day. Optionally, we can also specify three additional numbers for hours, minutes, and seconds. The new keyword that we have used here is used to create the instance of datetime struct. We will try to cover this keyword when we discuss more about creating custom types using structs, classes, and records. Sometimes, instead of exact date and time, you may just want to store a specific date value. For example, you may want to store date of birth for your customers, and so that your application can send them emails about special offers. Or for some applications, dates are not important at all. For example, when you are working on an application for setting daily reminders, you may not be really interested in the date part. For handling such data, .NET 6 introduced two new types, date only and time only. These types can be used for such purposes. Date only, as the name suggests, holds only date value, and time only holds only time value. Like date time, both date only and time only are structs, so they are also value types. We cannot assign nulls to variables of those types. For creating date only variable, we can use new keyword followed by the type name, and then inside the brackets we can specify three numbers specifying year, month, and a day of a date respectively. For creating time only variables, the syntax is similar. We need to use the new keyword followed by the type name, and then inside the brackets we can specify three numbers, and those three numbers are for hour, minutes, and seconds. Okay, now let's say we declare two variables of type time only, and now we want to find out the difference between those two variables. For this purpose, we can use minus operator. The result of this operation will not have time only type. The data type of the result is time span. The time span is another struct provided by C#. It is also a value type. If we want to declare a variable of time span type, then it is exactly same as declaring a time only variable. We need to specify the new operator followed by the type name, and then inside the brackets we can specify hours, minutes, and seconds. Although time only and time span declaration is similar, semantically they carry different meanings. Time only is to hold a specific time of the day, while time span is to store the interval between two time instances. For example, let's say we declare a time only variable which holds value of 1 p.m. and then we create another time only variable which holds value of 5 p.m. Now, if we calculate the difference between these two time only values, the resulting time span will contain 4 hours. Let's move on to the final topic of the discussion. Till now, when we declared variables of any type, we explicitly specified the data type. But there is one more way. Instead of specifying data type before the variable name, we can also specify var. Var is a keyword in C#. A var is permitted only if you are initializing the variable on the same line with some value. So a variable declaration like var x equal to 10 or var y equal to, in double quotes, hello is perfectly fine, but var z is not going to work. It will result in compile time error. In some languages like JavaScript, var is used to declare variables, and then any type of value can be assigned to the var. So, for some time, same variable can hold integer value, and then after some time, the same variable can hold, let's say, a string value. This type of languages are called as dynamically typed languages. But C# is strongly typed language. Compiler should know the type of a variable at the compile time, and it cannot change during runtime. A variable of a type can only hold a value of that type. So, how does compiler knows the type when a var is used instead of data type? In most of the cases, when we assign a value to a variable, the expression on the right side of the assignment operator is evaluated. The evaluated value also has a type. During the compile time, compiler tries to understand the type that would be resulting after evaluating the right side expression. And then the compiler tries to look at the variable's data type. If the variable's data type is specified explicitly, then compiler ensures that it matches with the data type of the value of right side expression. If they are same, then there are no errors. If var is used instead of explicit data type, then compiler replaces var with explicit data type that was derived from the evaluation of right side expression. So when we specify var x equal to in double quotes text, compiler replaces var with a string. When we specify var span equal to new time span, compiler detects that the type on the right hand side is time span, and therefore it produces the compiled code to use the explicit type time span. And if you declare var temp and you don't specify the value, then the compiler is not able to figure out the explicit type that should be assigned to temp, and thus compiler throws an error suggesting to specify data type for the temp. So the compiled code would never contain var. Bottom line is, var is just a syntactical sugar added to save some keystrokes for developers. It also helps in making the code easy to read in some cases. If you have used var and compiler is not able to figure out the right data type, then your code may get compile time error suggesting to specify the type explicitly. We have covered many concepts now, and I think you should have good understanding of the basics. Below are some exercises that you can try. Exercise 1, declare few variables and then try to print their values. Exercise 2, declare various numeric type variables and try to perform some arithmetic operations. Exercise 3, declare a variable of decimal type and another variable of double type and then try to perform some arithmetic operations. This might be a little tricky. Exercise 4, perform subtraction on two time-only variables and print the result. Try these exercises and let me know how it goes.
In this chapter, we will start discussion with the concept of type convergence. Then, we will see how to read inputs from the user. We will also have a look at how to set font colors for the text that is printed by using console.writeLine. Let's begin with the basics that we have covered yet. We declared variables and we used console.writeLine to print their values. All those lines of code had one thing in common. Every line of code was ending with a semicolon. In C#, every statement of code ends with a semicolon. Let's have a look at two new commonly used concepts, expressions and statements. An expression is something that evaluates to some value. For example, a plus b or a plus b minus c. These statements will evaluate to some numeric value. Subtracting a time-only variable from another time-only variable will also evaluate to a value of type time span. Expressions can also be nested together. For example, a minus b is one expression, c multiplied by d is another expression, and we can nest them together for a division operation. And then let's have a look at what a statement is. A statement does not return a value but does something. For example, console.writeLine is a statement because it prints the text, but it actually does not return any value. Okay, let's move on to the next section. Let's have a look at the exercises from the last chapter. Did you get chance to try them? First, second and fourth exercises were easy, but the third exercise was a bit tricky. Let's start our discussion with that exercise. The exercise was to create a decimal variable x and a double variable y and then perform some arithmetic operation. So let's add a statement to add x and y and store the result in some variable. Now let's try to run the program. we get the compilation error. The error says that the operator plus cannot be applied to operands of type double and decimal. Operand is the new word here. Let's understand what it is. Every line of code in the program is an individual instruction. An operand is part of instruction which specifies the data to be manipulated or operated on. So, in case of this line, these two variables specify the numbers which should be operated on, and that's why those two variables are operands. This error is saying that we cannot perform addition of these two variables because the data types are not matching. So what can be done here? We already know that the type of a variable cannot be changed at runtime. Of course, we can modify our program and then change the data type of one of the variables so that the data types match and program would function as expected. But in real world programs, we may not have such flexibility to change data types as per our wish. And that's why in such scenarios, we use type conversions. Type conversion can either be done by using typecasting or by using a helper class. Typecasting is used for converting a value of a given type to a value of another type. Typecasting can either be implicit or explicit. Let's see what is implicit typecasting. Implicit typecasting is simple. It doesn't require any extra syntax and it doesn't cause any data loss. An implicit casting can be made when a value to be stored can fit in the target type without being truncated or rounded off. For built-in numeric types, it means if the range of a source type is a subset of range of the target type, then implicit conversion can happen. For example, byte variable can be assigned to a short variable without any problem. And we can also assign a short variable to an int variable without any additional syntax. And similarly, an integer value can be assigned to a long value. In explicit typecasting, expression like this in bracket t followed by e is used, where t is the target type and e is the source variable. If no explicit conversion exists from the type of source variable e to the target type, then a compile time error occurs. At runtime, an explicit conversion might not succeed and explicit casting might throw a runtime error. From decimal to double, an explicit cast exists. So, we can just cast our double variable y to decimal type. We can store the typecasted value into a temp variable and then we can use this temp variable for arithmetic operation. Or we can simply drop the temp variable and directly use the typecast expression inside the arithmetic expression. Sometimes type conversion is not possible by using either implicit casting or explicit casting. For example, let's say we create a variable of type string and then assign 10 inside double quotes to that variable. Then if we define another int variable and try to perform explicit typecasting, it will not work. So what can we do now? In such cases, we can use conversion using a helper class. C# provides a helper class convert. We can use a method convert.toInt32 to convert a string to an integer. Note that the conversion would be successful only if string contains only digits. If conversion is not successful, it may result in runtime errors. Runtime errors are also known as exceptions. This convert class also provides many other methods like toString, toInt32, toInt64, toBoolean, etc. But wait, what is int32 and int64 now? So let's start from beginning. .NET implementation is language agnostic. This means that .NET supports multiple languages. Whether you write code in C# or VB.NET or in any other language, when you compile the code, it is converted into an intermediate language code. Runtime only understands intermediate language, and that's how multiple languages are supported by .NET. In order to support flawless, transparent cross-language integration, .NET provides some rules and specifications that every language must follow in order to be supported by .NET. Common Type System is part of those specifications. Common Type System, also known as CTS, describes all the data types that are supported by .NET Runtime. CTS also includes rules that all language must follow when it comes to working with those data types. For example, CTS enforces that int32 can only be 32 bits in size. It is a numeric type, so it should support arithmetic operations. Like this rule, there are many such rules specified in CTS. CTS provides various primitive types as a part of system namespace.
When we install .NET SDK, all those types are available for us and we can use them for application development. CTS defines various types in its specifications, and all those types can be categorized into 5 categories: classes, structures, enumerations, interfaces, and delegates. We have covered basic idea about classes in chapter 2. Rest of the types we will cover in coming chapters. .NET Common Type System defines some primitive types like int16, int32, int64, etc. These are all defined by using structures. A .NET language can alias these types. For example, .NET type is int32 for 32-bit integers, but in C#, int is an alias for the same type. In VB.NET, integer is the alias for 32-bit integer, and so on. C# has aliased int16 as short, int32 as int, and int64 as long. Similarly, C# types unsigned short, unsigned int, and unsigned long also have their primitive counterparts with prefix u. Bottom line is, short, int, and long are aliases of .NET primitive types int16, int32, and int64. Similarly, ushort, uint, ulong are aliases for unsigned primitive types uint16, uint32, and uint64. They are basically just another names of the same data type. Now let's come back to the type conversions. So for converting a string 10 into integer 10, we just need to use convert.toInt32 and pass string variable inside the brackets as input. Similarly, let's say there is a string variable that contains true in double quotes, and let's say we want to convert it to a Boolean type. Then we can call convert.toBoolean method to convert this string into Boolean value. In addition to convert class, many types provide methods for type conversions. For example, int provides method int.parse, which can be used to convert a string to an integer. Other numeric types like decimal, double, float also provide similar methods to convert string inputs into numeric value. Numeric values are probably easy to convert. Just some digits and optionally decimal point inside the quotes. Converting from string to datetime is bit tricky. Datetime provides 3 different methods for conversion: parse, try-parse, and parse exact. These 3 methods can help to parse a string value to a datetime value. Date is specified in different formats in different countries. Sometimes the date is specified in year, month, day format, while in some countries the format may be year, day, and month. Parse method basically takes 2 important parameters: a string value which needs to be converted and the culture info, which would tell .NET how string value should be parsed. The culture info would tell which part of string should be considered as date and which part of string should be considered as month and which other part of string should be considered as year, and so on. Try-parse method is also similar. It takes string value to be converted and the culture info object. If the conversion is successful, try-parse returns true, and the converted value is returned in the form of an out variable. Parse exact is another method which can be used to convert a string value into a datetime value. Parse exact also has 2 parameters: the actual string value which needs to be converted and the format which should be used to parse the string. This format may contain letters. Lowercase d is for day, so 2 D's means date will always contain 2 digits starting from 01 till 31. Uppercase M is for month. 2 M's specify the month number and that number will always contain 2 digits. Lowercase y is for years. 4 occurrences of y specify that year would be specified by 4 digits. Optionally, we can also specify the time part. Uppercase h can be used to specify hours in 24-hour format. Lowercase m can be used to specify the minutes part of time, and lowercase s can be used to specify the 2 digits of seconds. Optionally, we can also specify a separator like a backslash character or a hyphen or just a white space to separate different components of date part and time part. So let's say we want to convert a string value 26 January 2022 into a date time. So let's say the value was specified like this. Now if you want to convert this into a datetime value, then we can use datetime.parseExact and then pass the input string value as the first parameter, and then we can specify the format dd mm yyyy, and it should convert the string value to a datetime value. We can also add the time part if required. This should give you idea about how to convert a string value to a date only or time only type.
I think we have covered all the basics of converting a built-in type into another. Let's move to the next part to understand how to read inputs from the user. In console applications, we can use console class for reading from the console as well as printing something to the console. In this chapter, we are going to discuss three methods: console.readLine, console.readKey, and console.read. Console.readLine is simple. When .NET is executing this line of code, the console provides a cursor and we can start typing the input. We can keep typing until we hit enter. When we hit enter, all the characters that we entered are returned as a string. If we press enter without providing any input, then it would return an empty string. The second method is console.readKey. When .NET is executing this line of code, it will allow user to type something. But the difference is it will only wait for single key to be pressed by the user. It does not wait for user to press the enter. So as soon as you press the key, next line of code would be executed. The return type of this method is console key info, which is a struct. This returned value contains information about the character that was pressed. Console.read is the third method that we want to have a look at. When .NET is executing console.read, it also provides a cursor on the console and we can type anything that we want. This method waits until we press enter key, but it will return only the first character that we have entered. That's how it is different from console.readLine. Console.readLine provides the entire input until the enter was pressed, while console.read provides a single character that we have entered. In fact, the first character that we have entered on the console. The return type of this method console.read is integer, so it will return the integer value for the corresponding character. Console class also provides methods to alter font color of the text that will be printed. Console.foreground color is used for that purpose. We can set this property to any color of our choice. If we want the default colors back, then we can just call console.resetColor method. Similarly, console class provides two methods to print the text. One is console.writeLine that we already have seen, and the another is console.write. So what is the difference? Console.writeLine prints the text and then also prints a new line character. So anything that you print after would be printed on the next line. And console.write just prints the text that we have passed. It doesn't print the new line character. So if you call console.write multiple times one after the other, all the text would be printed on the same line. Now let's write some code. We are going to write a code which asks three questions, and the program will also allow to input the answers. Let's say in the first question we want to ask the name of the user. So let's add a console.writeLine and pass the text, what is your name? This text will be printed on console window. Now we need to allow user to enter the name. Name can contain multiple characters and we want all those characters to be returned. So in this case we are going to use console.readLine. The return type of this method is string, and we are going to store this string value into a variable called as name. Note that although we have used var here for declaring the name variable, compiler can derive its type to be string, as the right side expression console.readLine returns a string. Now let's add another question asking about date of birth. So another console.writeLine, and we will pass the text asking for date of birth of the user in DDMMYYYY format. Date of birth can also contain multiple characters. So again, in this case, we will use console.readLine and store the returned string value into a variable called as string date of birth. Let's use type conversion now to convert this string date of birth into a date only type. We will use dateOnly.parse exact method, and we will pass the input value and the expected date time format DDMMYYYY. This should convert string date of birth into date only type. Now let's ask another question. Let's say we want to ask user how many languages the user can speak. So another console.writeLine to print the question. The number of languages can be any number. It can contain multiple characters if the number is greater than, let's say, 10. Let's say if user knows more than 10 languages. And that's why here also we are going to use console.readLine, which will return us a string value, and then we can use convert class to convert the input value into an integer. Now let's try to print all the parsed values on the console. To identify the area where we are printing parsed input values, we will set foreground color, that is the font color, to be yellow. Note that foreground color is a property and it can be set to any value from console color enum. Console color enum contains a lot of different values, each representing a different color. Let's select yellow from the list and then add 3 console.writeLine to print the parsed values: name, date of birth, and number of languages user can speak. Till now we have used only console.readLine, which returns multiple characters entered by the user. We have not used console.readKey yet, which returns only a single character.
So to demonstrate how to use console.read key, let's try one thing. Let's first reset the console colors to their default values by calling console.resetColor, and then add a console.writeLine asking user to press any key to exit the program. As this time we need a user to press any single key, we will use console.read key. Also, we do not care which key was entered by the user, so we will not really assign the character value returned by console.read key to any variable. After console.read key, let's add another console.writeLine to tell user that program is exiting. Now let's try to run the code. Program will ask 3 questions. We can provide answers to those questions. The program will also print the parsed input values in yellow font color. After that, program will ask user to press any key to exit. As soon as we press any key, program will try to execute the next line of code which prints exiting message on console, and then the program exits. So we have covered how the type conversion works and how inputs can be read from the console. You can also try using console.read instead of console.read key to understand the difference between those two methods. Below are some exercises that I would recommend you to try on your own. First exercise is take 2 integers as input and then perform arithmetic operations on those 2 numbers. After that, print the results. While printing, you can also try to play with foreground color to print the results in different text colors. Exercise 2 is input 2 decimals and then perform arithmetic operations and then print the results. It is very similar to the first exercise. In second exercise, we are supposed to use decimal as the data type, while in first exercise, we are supposed to use integer as the data type of the 2 numbers. The third exercise is input a single integer and then add int.maxValue to it and then print the result. Let me know if you get the expected result. Fourth exercise is for calculating simple interest. So input principal amount, duration in number of years and rate of interest per year, and then calculate the simple interest using the formula P into N into R divided by 100. Try these exercises and let me know if you face any difficulties. In the previous chapter, we have discussed about type conversion. We also have discussed about how to read inputs in a console application. In this chapter, we are going to discuss about decision making and conditional statements. For writing conditions, we also need to know some comparison operators. We are also going to have a look at them. The chapter will begin with a quick introduction to if statements. In the second section, we are going to discuss about switch statement and switch expression. In the end, we will have a look at ternary operator and null coalescing operator. So let's get started. We commonly use many conditional statements in our day-to-day life. For example, if it is raining, then I will have to take my raincoat with me. If I get good bonus, then I will plan a nice vacation in the summer. Or if I become the president of this country one day, I will lower the taxes. Similarly, a computer program may also need to take some decisions. We all know that a computer program is a set of instructions. Those instructions are executed step by step by the computer. Every instruction is to perform certain tasks. And in some cases, program may need to take certain decisions based on the outcome of previous tasks. Let's take an example. Let's say we want to write a program which takes a number as input, and then the program needs to display the text indicating whether the input number was even or odd. A number is even if it can be divided into 2 equal groups. It means if we divide that number by 2, the remainder should be 0. So based on this mathematical condition, our program needs to decide which text should be printed. For taking such decisions, we can use if statements. The if statement begins with if keyword followed by a condition inside the bracket. The condition inside the bracket must always evaluate to a Boolean value, indicating whether the condition is satisfied or not. So let's have a look at the sample code. The sample code shown here takes a number as input. Then the next instruction is to find out remainder after dividing the number by 2. The percentage sign here is also called as modulus operator. It is used to find the remainder after the division. Note that / is division operator. It tells us the result of division, while the modulus operator is for knowing the remainder after performing the division. So now that we know the remainder, we need to decide if the remainder is 0 or not. So for that, we can write an if statement, and in the brackets, we can check if remainder equals to 0. This condition here checks if the remainder is 0 or not. And if this condition is satisfied, then the control of execution goes inside the if block and prints the text. You must already have noticed that we have used double equal to sign. In C#, single equal to sign is for assigning the values, while double equal to sign is for comparing the values for equality. You must have also noticed the curly brackets after the if statement. Those curly brackets should contain the code block which needs to be executed when the condition is true. In this example, if the condition is true, we just want to display that the number is even. So we just need a single statement console.writeLine to print the text. Note that if there is a single statement to execute, then the curly brackets are not required. They can be dropped. But I generally prefer having the code block surrounded by the curly brackets to explicitly mark the boundaries. Currently, our program just identifies if the number is even. If the number is odd, it doesn't print anything. So what can we do to add another alternative path of execution in our program? For that purpose, we can use else block. The else block is executed when the condition specified in the if is not satisfied. That is, the condition specified inside the if should evaluate to false. In our program, there can be only two possible values for remainder. The remainder can be either 0 or it can be 1. And if the remainder is 1, that means the number is odd. We already have handled one possible case in the if block. When the condition specified in the if statement is false, then the control skips the execution of the if block and it goes to else block only if else block is present. And that's why for printing that the text is odd, we just need to add an else block which starts with an else keyword followed by curly brackets. And inside these curly brackets, we can add console.writeLine to print that the given number is odd. Here as well, curly brackets are optional. If the else block contains a single line of code, then curly brackets are not required. But I would again recommend to keep using curly brackets to avoid any confusions while reading the code. The code that is written between these curly brackets is called as if block, and the code that is written between the curly brackets followed by an else keyword is called as else block. Note that else block is completely optional. If we do not want to perform any action when the condition specified in the if statement is false, then we can simply have an if block without any else block. Program was supposed to handle only two possible outcomes of one condition, and that's why adding a single if else was sufficient. But what if decision making is more complex? What if the decision has more than one condition and more than two possibilities?
Now let's look at another example. Here we need to decide the grade of the students based on their score. Grade can be either A or B or C based on the bucket in which score falls. The flowchart here shows the step-by-step instructions, and we are going to use this information to write our C# program. This flowchart is showing series of conditions. The first condition is to check if the score is greater than or equal to 90. Here we have used a greater than sign followed by an equal to sign to check the greater than or equal to condition. If this condition is true, then it prints that the grade is A. But if this condition is false, then the next condition comes into play. The next condition is for checking if the grade is B. If the next condition is true, then the program prints the text corresponding to B grade and program exits. If the condition is false, then the third and last condition is executed. If the third condition is true, then the text for grade C is printed. If the third condition is false, then the program prints that the student is failed. Now here the failed text would be printed if the score does not fall into any of the three buckets specified by three previous conditions. That is, all those three conditions should be false. For programming such decisions, we can use if and else syntax. Let's now convert this flowchart into a C# program. The C# program will start with an instruction for accepting a number as input, and then there is an if statement to check if the score falls into the first bucket. If the condition is satisfied, then the program prints the text corresponding to grade A and program exits. In this case, it doesn't check any further conditions. If the condition for grade A is not satisfied, then the next condition is evaluated. Here, the next condition is specified in else if statement. Else if also behaves similar to if statement. If the condition specified in the else if is satisfied, then the text is printed and program exits. When the condition for grade B specified in else if block is not satisfied, then the next else if condition is evaluated. The execution goes like this until the else block is found. When the condition specified in an else if block is not satisfied, then the next else if block is evaluated. And this goes on. If none of the else if blocks evaluate to be true, then an else block is executed if it is present. So, else block is executed only if all previous conditions specified using if statement or else if statement are false. Here also, else block is optional. We can skip it if we don't need it. So, in short, when we want to perform any decision making in our code, we can use if statements. The if statement can optionally be followed by one or more else if statements, and an else if statement can optionally be followed by an else block. The else if blocks are evaluated in the order in which they are specified. If one else if condition is false, then the next else if condition is evaluated, and this goes on. Okay, now we know enough about if statements, but for writing conditions, we will need to know about comparison operators. So on this slide, let's have a look at commonly used comparison operators. operators. Some commonly used comparison operators are greater than or equal to, less than or equal to, and then equality comparison and inequality comparison. We use same symbols for comparison that we use in regular mathematics. Just for checking the equality, we use double equal to sign. As stated earlier, single equal to sign is for assigning the values, while double equal to sign is for comparing the values for equality. An exclamation mark followed by an equal to sign is used for checking that the two numbers are not equal. The comparisons are straightforward for value types. The comparison operators will just compare the values and they will return a Boolean value indicating whether the comparison was satisfied or not. For reference type, comparison is bit different. So let's take an example. Let's say there are two objects P and Q. Both are of same reference type and both of them contain the same value as shown in the picture. And now if we use equality operator to check if P and Q are equal, the comparison would return false. Why? Because by default the double equal to sign compares the references for reference types, and as P and Q are pointing to the different memory locations, the equality check would return false. Optionally, we can change the behavior of this double equal to sign for a reference type by using operator overloading. We are going to learn about operator overloading later in this course. Now it's time to write some code. Let's say we take two numbers as input and then we need to print which number is greater. For that, we can start with console.write for asking user to input a number. And then let's say we add console.readline to take the input in a variable called as temp. After that, we can use convert class to convert the input value from string to decimal. We can also avoid having a temp variable and we can write a code like this where console.readline is being passed as a parameter inside the brackets of convert.toDecimal. C# always evaluates innermost brackets first while evaluating any expression. So in this case, console.readline will be evaluated, which returns the user input as a string, and this returned string value will be passed as a parameter to convert.toDecimal for type conversion. After that, let's say we want to print an empty line. For printing an empty line, we can just call console.writeLine without passing any parameters to it. Now, I will copy the same syntax for reading the second number. So we have a code now which accepts two numbers as input. Now the code needs to decide which number is greater. There are three possible cases in this problem statement. First case, where first number is greater than the second number. Second case, where second number is greater than the first. And the third case, where both numbers are equal. So let's start with the first case. We will add an if statement and we will check if first number is greater than the second. Here we have used greater than operator, and now if this condition is true, we want to add a console.writeLine to print that first number is greater. There are two remaining possibilities and hence we cannot use else here. Else block is generally used to make if statements exhaustive. This means else covers all the remaining cases which are not satisfied by the if condition. As there are two conditions in our case, we will add else if, and this else if will be followed by the condition to check if second number is greater than the first, and if this condition is true, we are going to print that second number is greater than the first one. Now the last possibility is remaining. In the last possibility, both numbers would be equal, but as there were only three possibilities and we already have explicitly checked two possibilities by adding the conditions, we can just add an else block here. In this else block, we can just add a console.writeLine to print the text that both the numbers are equal. Let's try to run the program and enter 10 as first number and 20 as second number. The program correctly prints that second number is greater. If we run the program again and enter 200 as first number and 100 as second number, then the program correctly prints that first number is greater. And third time when we run the program, we will provide equal numbers and the program correctly identifies that both numbers are equal. It seems our program is running as expected. You must already have noticed that program does not check subsequent conditions after a matching condition is found. Now let's write another program. Let's say we want to write a program to accept a number as input. This number is supposed to be some kind of percentage, and let's say we want to implement a rule that this number should always be between 0 and 100, where 0 and 100 are allowed values. This time we are going to use console.write instead of console.writeLine for asking the user input, and then the same syntax console.readline for reading the input, and then convert.toDecimal to convert the string value into a decimal value. So we have the input ready. Now we want to check if the value is between 0 and 100. So basically there are two conditions to check. The number should be greater than or equal to 0 and number should also be less than or equal to 100. Let's start with an if statement where we are going to add a condition to check if percentage is greater than or equal to 0. We are using greater than or equal to sign because 0 is also a valid value. Okay, we have an if statement ready now. We still have not checked for the other condition. So inside this if statement, we can add another nested if statement checking if the percentage is less than or equal to 100. If this nested statement is true, then we will add a console.write line to print that input is valid. Now if the input is invalid, then we also want to show the user that the input provided was invalid. How are we going to do that? Let's say for now we add an else block for the nested if statement. Let's run the program to see if program executes as expected. Enter a valid value 99. Program correctly prints that the value is valid. Now run the program again and let's input 101. Program correctly prints that the value is invalid. Next, run the program again and input another invalid value -1. This time program does not print anything on the console. But why? This is because we have added else block only for nested if statement. The nested if statement will be false if the number is greater than 100. But there is also a top level if statement which checks if the number is greater than or equal to 0. And for that if statement, we have not added any else block. And that's why when the number is negative, program doesn't print anything. Let's add an else block here for the top level if statement and let's print that the number is invalid if it is negative. Now if we run the program again and we provide any negative value as input, the program will correctly identify that input is invalid. Although we could make the program work by using nested if statements, there is also another way. We can combine both the boundary conditions together in one condition. For that, we can use conditional AND operator. But before that, let's have a look at all the operators which can be used to combine the conditions. As shown on this slide, there are two conditional operators which can be used to combine the conditions. Let's start with conditional AND operator. A conditional AND operator returns true if both the conditions that it combines evaluate to be true. The conditional AND operator evaluates the left side condition first. If the left side condition is evaluated to be true, then the right side condition is evaluated. If the left side condition is evaluated to be false, then the right side condition is not evaluated and the whole combined expression returns false. The other operator is conditional OR operator. It is represented by two vertical lines, sometimes also called as double bars. If conditional OR operator is used to combine the conditions, then the combined conditions returns true only if one of the two conditions is true. Conditional OR operator evaluates left side condition first. If it is true, then the right side condition is not evaluated and the whole expression returns true. If the left side condition is false, then the right side is evaluated. Similar to these conditional operators, there are also some other Boolean operators. We already have seen a negation operator represented by an exclamation mark. This is a unary operator. It means that the operator needs a single operand. It logically negates the operand's value. For example, if the operand is true and if the negation operator is applied to it, then the expression will return false. Similarly, there are three more operators. Let's have a look at logical AND operator. It is represented by a single ampersand character, and the logical AND operator is a binary operator, so it needs two operands. It returns true if both the operands evaluate to be true. The next is logical OR operator. It is represented by a single vertical bar. It is a binary operator, so it needs two operands, and it returns true if any one of the operand evaluates to be true. The third operator is logical exclusive OR operator or logical XOR operator. It returns true if both the operands are not equal. So it produces same result as inequality comparison. So after looking at these Boolean operators, we may have one question. The logical AND operator seems to be producing the same outcome as conditional AND operator. And similarly, the logical OR operator also produces the same outcome as conditional OR operator. And the obvious question is, what is difference between conditional operator and logical operator? Let's start with logical AND operator. Although logical AND operator produces the same outcome as conditional AND operator, there is one difference. The logical AND operator evaluates both the operands before returning the result, while conditional AND operator does not evaluate the right side operand if left side operand evaluates to be false. Similarly, logical OR operator also differs from conditional OR operator in the same aspect. The logical OR operator evaluates both operands, while conditional OR operator may evaluate a single operand if the left operand is found to be true. Now that we have seen all the operators which can be used to combine the conditions, let's continue with our previous code example. In this code example, the input is valid if the input falls between 0 and 100. We implemented this validation by using nested if conditions. We can change this implementation and use the conditional AND operator instead. So let's remove this code and add a new if statement and then combine both the condition by using conditional AND operator like this. If this condition is true, then we will add a console.write line to print that input is valid. And if this condition evaluates to be false, then a single else block would be sufficient to print that the input is invalid. Now if we run the program again and provide negative value as input, or if we provide any value which is higher than 100, then the program will correctly identify that the input is invalid. In certain cases, we may need to use more than one operators to combine multiple conditions together. If the combined conditions contain multiple conditional operators, then the operator precedence decides the order in which the expression will be evaluated. This slide shows default order of precedence. If the expression contains negation operator, it is evaluated first. This is followed by the logical AND operator, logical XOR operator, and logical OR operator in that particular order. After logical operators are evaluated, conditional AND operator and conditional OR operator are evaluated in that order. This is the default order of processing, and this default order can be changed by using the parenthesis. And if we used parenthesis, then the innermost parentheses are evaluated first. To understand the concept of operator precedence, let's take another code example. In geometry, a triangle can be categorized into one of the three categories. It can be equilateral triangle if all the three sides have same length, or it can be isosceles triangle if any two sides have the same length, or it can be a scalene triangle if all the three sides of the triangle have different lengths. We will write a program to accept three numbers as input. Those three numbers represent the lengths of three sides of a triangle, and then our program will identify the category of the triangle. So let's begin the program with a console.write statement. Here we are going to ask user to provide the length of first side of the triangle. After this, let's add console.readLine to read the input, and then convert.toDecimal to convert the string input into decimal. We are using decimal type here because the length can be specified as a number which contains a decimal point. In fact, for that matter, we could use float or double, but let's use decimal for the sake of this demo. Okay, so we have got all the required inputs. Now let's see which decisions we are required to take. Let's start with deciding if the triangle is equilateral or not. Checking for equilateral triangle is simple. We just need a if statement to check that the length of first side is equal to length of second side, and the length of second side is equal to length of third side. Here we are using conditional AND operator to combine the conditions. Inside this if block, we can add a console.writeLine to print that the triangle is equilateral. Okay, first case is done. In the second decision, we will check if the triangle is isosceles. So let's add an else if. We are adding else if statement because we want to execute this condition only if the previous condition is false. The else if condition here is a bit tricky. We need to check that any two sides of triangle are equal. There are three possibilities. Maybe first side and second side have same length, or maybe second side and third side have same length, or the other possibility is third side and first side have same length. If any of these three conditions is true, then we want to display that the triangle is isosceles. And that's why here we will use conditional OR operator to combine the conditions. Now if this condition is true, then the control will go inside this block, and inside this block we will add a console.writeLine to display that the triangle is isosceles. If the triangle is not equilateral and if it is not isosceles, then it must be scalene. So we can just add a simple else block, and inside that else block we can add a console.writeLine to display this message. Okay, it seems our program is ready. Let's try to run the program. First provide the inputs 12, 12 and 12. The program correctly shows output that the triangle is equilateral. Now run the program again, and let's provide 12.5, 12.5 and 13 as inputs. The program output shows that the triangle is isosceles, which is also correct. Now run the program again and provide three different numbers as input. Let's say 3, 4 and 5. In this case also, program shows correct output that the triangle is scalene. So let's have a closer look at the program. The first condition is to check whether a triangle is equilateral or not. And hence, in the else if block, we already know that all the three sides are not equal. And that's why specifying this condition is sufficient. But let's say instead of checking for equilateral triangle first, we want to check for isosceles triangle. So I will now reorder the conditions and let's try to run the program. Now, if I provide equal lengths for all the three sides, the program shows output that the triangle is isosceles triangle. Although technically it is also an isosceles triangle, we wanted our program to print more specific category, that is equilateral triangle. What can we do now to make this condition in the if block stricter? Now this particular condition contains three subparts. Currently each subpart is checking whether any two sides of triangle are equal or not, and each subpart checks the length of two sides. But what it is missing is it should also check that the length of third side is different from the length of remaining two sides. So in the first subpart of the condition where we check that the length of first side is equal to length of second side, we will use conditional AND operator to add one more condition that the length of first side is not equal to the length of third side. And we will make similar modifications in remaining two subparts. Now this condition has become very long and it uses two different types of operators.
conditional AND operator and conditional OR operator. We have not specified any additional parentheses here. So the default order of operator precedence will be used to evaluate this expression. Sometimes in the real world applications, the conditions can be very complex, and that's why it may be better to use parentheses to explicitly specify the order of evaluation. In this example, if we want, we can also explicitly add parentheses around the 3 subparts like this. But even after adding them, the expression would be evaluated in the same order, and hence the behavior of program will not change. The point to note here is, sometimes it is better to add parentheses to make the conditions more readable. If the conditions are more complex to understand in the first look, then we can also extract the condition into a method which returns a Boolean value, and then call that method from the if statement. I hope this example was useful to understand the order of operator precedence. Let's move to another type of conditional statement, a switch statement. A switch statement takes an expression as input. Inside the switch block, there can be multiple case blocks. Every case block starts with a keyword case followed by an expression or a constant value. The expression mentioned in the switch is compared with expression from each case. As soon as the first match is found, matched code block is executed. Every case block ends with a keyword break. This break keyword passes the control of execution outside the switch statement. Instead of break statement, we can also use return statement to return from the method which contains the switch statement, or else we can use a throw statement to throw a new exception. Switch statement may contain a default case at the end. This default case is very similar to else block in if statements. If no matching case statement is found, then the default code block is executed. If the switch does not contain the default code block and none of the cases matched with switch expression, then the control just falls through the switch statement. Until C#6, the switch statement was little different than it is today. At that time, it was allowing only constants in the case statements. Expressions were not allowed. This snapshot shows one example of the switch case statement with constants. Note that this syntax is still valid with the latest versions. Starting with C#7, any expression can be specified in the case statement. For example, the code shown here has 2 cases with expressions. One case checks if the percentage is less than 0, while the other case has expression to check if the percentage is greater than 100. If any case statements matches with the expression specified in the switch statement, then the corresponding code block would be executed. Till now, we have had introduction to keywords like switch, case, default, and break. There is one more keyword which is used with switch statements. The keyword is when. Every case can also have guards. A guard is an additional condition that can be specified using the when keyword. If we look at the sample code shown here, the case has a guard specified. The case block would be executed only if the value in number variable is equal to 25 and the value in another number variable is equal to 20. Here, the condition specified using another number variable is the case guard for this particular case. We already have seen what is the difference between an expression and a statement. An expression evaluates to some value, while statement is a line of code that just does something. Till now, we were speaking about switch statement. In C#8, a new expression was introduced, switch expression. The syntax of switch expression is very similar to the syntax of switch case statement. The only difference is, being an expression, switch expression must always return a value or throw an exception. Switch expression is also like a switch statement. It starts with switch keyword. Instead of cases, switch expression contains expression arms. The expression arms are separated by comma. Each expression arm may contain a guard. The syntax of guard in switch expression is same as syntax of guards in switch statement. Each arm expression is supposed to evaluate to a value. When switch expression is executing, the expression from the switch is compared with each expression arm. As soon as the code finds the matching arm, the corresponding code block is executed. The corresponding code block is also an expression, so it should evaluate to a value, and that value is returned by the switch expression. Instead of default keyword, the discard pattern is used in switch expression. The underscore used in this sample code is the discard operator. It matches to any value, including null. It works like default case. If the value of switch expression matches to the value of any expression arm, then that particular arm is executed. Otherwise, the discard arm is executed.
Okay, that was the quick introduction to switch statement and switch expressions. Now let's try to write some code using switch keyword. Let's first start with switch statement. Let's say we want to write a program that takes a number which is between 1 and 7. Both 1 and 7 are valid values. And based on the input, we want to print the text telling which day of week this input number corresponds to. For example, if 1 is the input, then the program will print Monday. For 2, the program will print Tuesday, and so on. So let's add our code to ask for input number. After that, we can add the switch statement, and after the switch keyword, we can specify the input number variable. Now inside this switch statement, we can add one case for each day. Let's start with case 1. If the switch expression matches with this particular value, we want program to print Monday. So inside case 1 block, we will add a console.writeLine to print Monday. And that's what basically we wanted to do if input number is equal to 1. So after console.writeLine, we will add a break statement so that the control goes out of the switch statement and it doesn't execute the subsequent cases. Similarly, we will add cases for remaining days of week. We can also add a default case to print that the number was not valid. This case would be executed if number was not between 1 and 7. Now if we run the program, we can see that program is correctly executing the code and we can see appropriate outputs. Now let's try to write switch expression instead of switch statement. As we know, switch expression must return a value. In our case, we want that value to be a string. So let's declare a string variable, day of week. After that, add an assignment operator followed by the input number variable, and after input number variable, a switch keyword. Now inside the switch, we can add expression arms. Let's start with arm for constant value 1. In switch expression, instead of colon, we use equal to and greater than sign to begin the corresponding code block for an expression arm. If the input number is 1, we want to return Monday. So here, just add Monday in double quotes. Similarly, add cases for rest of the days of week. At the end, we can use discard operator to return the text corresponding to invalid input. Now, the day of week variable contains the text that we need to print. So after the switch expression, we will add console.writeLine to print the value of that variable. Okay, I hope this code example was helpful to understand the concept of switch statement and switch expression. Let's move on to the next section. In this section, we are going to have a look at two operators. The first operator is ternary operator. A ternary operator sometimes is also called as conditional operator. This slide shows the syntax of ternary operator. It starts with a condition followed by a question mark. Then the question mark is followed by an expression which should be executed if the condition is true. This expression is followed by a colon character. This colon character is then followed by an expression which should be executed if the condition is false. This behavior is also similar to if-else statement. There is only one difference. The else part in if statement is optional, while the colon part in ternary operator is not optional. It always needs to be specified. The first code snippet on this slide shows the if statement for checking if a number is negative or not. In this code snippet, you must have noticed that we are not using console.writeLine to print values, but we are assigning the strings to a string variable. The same code can be rewritten using ternary operator as shown in the second code snippet. The ternary operator checks the same condition and returns the text to be printed. After ternary operator, the second operator that we want to understand is null coalescing operator. This operator is represented by double question marks. This is a binary operator, so it needs two operand. Left operand is followed by double question mark sign, and then it is followed by a right operand. The null coalescing operator checks if the left operand is null. If the left operand is not null, then the left operand's value is returned. Otherwise, right operand's value is returned. Let's move to the code. Let's write a program which identifies if a number is a two-digit number or not. A number is a two-digit number if it is greater than 9 and less than 100. So we can add this condition in our code. If this condition is true, then we can return a text saying that it is a two-digit number. And if this condition is false, then we will return the text that the number is not a two-digit number. The ternary operator is not directly calling console.writeLine to print the text. It is just evaluating to a string value, and then this string value we can print to the console by using console.writeLine. And now if we run the code, we can see that the code is producing the expected output. Next, let's try to understand null coalescing operator. Let's say we declare two string variables. The first string variable is null, while the other string variable is not null. It has some value. Let's say ABC. Let's use null coalescing operator on first string variable. As a right operand, we are going to specify some hard-coded text here. Let's say first variable was null. After this, let's let's use the same operator on second string variable as well. As a right operand of null coalescing operator, let's specify the same hard-coded text here as well. We can display the results on console by using console.writeLine. Now we can run the program and see that first result is printing the value of right operand as first string is null. However, second result is printing the value of second string variable. This is because the second string variable was not null. I hope these code examples were useful to understand the concept of ternary operator and null coalescing operator. Let's move on to the last section of this chapter. This slide shows some exercises that you can try on your own. The first exercise is to read 3 numbers as input and then print the greatest number. Second exercise is to read 3 numbers as input. Those 3 numbers should represent the length of 3 sides of a triangle, and then the program must identify if the triangle is a right angled triangle. Third exercise is to take 2 decimal numbers as input. The first number should be the height in centimeters, while the second number should represent the weight of a person in kilograms. Use these 2 numbers to calculate BMI. After that, the program must print the category in which BMI falls. Refer Wikipedia page to understand the categories of BMI. This would be helpful for you to decide which conditions are required in your program. Fourth exercise is to take a number as input which represents a year in Gregorian calendar, and then the program must identify if that year was a leap year or not. Okay, this brings us to the closure of this chapter.
In this chapter, we are going to discuss about loops and jumps. In the beginning, we are going to discuss some basics about loops. We will have a look at what are loops and what are some common sections when it comes to programming the loops. After this basic theory, we will move to iteration statements. Iteration statements are the statements which are used to create loops in C#. Later in this chapter, we will also have a quick overview of some jump statements. These statements can be used to unconditionally transfer the execution control from one point to another. Okay, let's get started. We already have seen this flowchart in previous chapter. This is a step-by-step set of instructions which can be used to decide if a number is even or odd. We converted this flowchart into C# code. We also tried to run this program for various inputs to ensure that program is running as expected. Every time we run the program, we could provide a single input and the program was printing if the number was even or odd. After displaying the output, program was exiting. So for trying another input, we had to run the program again. You must have seen this behavior. The question is, what can we do to run the program as long as user wants? The answer to this question is very simple. We can ask user if user wants to try another input, and then based on this input, program can decide whether it should repeat itself or not. Let's look at this flowchart now. This flowchart contains same steps from previous flowchart. The only difference here is the flowchart is not going to stop state after displaying the outcome. Instead of stop, we can add a condition statement here. This conditional step will ask user if user wants to try another input, and if user inputs yes, it means user wants to run the program again. That's why the flowchart will transfer the control to the beginning. If user inputs no, then it will mean that user wants to exit. In such case, flowchart will go to stopped state. This flowchart is explaining very core nature of the loop. A loop repeats set of instructions. Those instructions are repeated until some condition is true. The condition should always evaluate to a Boolean value. This condition can be a simple condition involving one single comparison operator, or it can involve any combination of comparison operators, conditional operators, and Boolean operators. By now, we have understood that loop contains 2 basic parts: the code that needs to be repeated and the condition which will decide whether code should be repeated further or not. There are 2 more sections that can be generally seen with the loops. An initializer section is the section where variables required for loop conditions are initialized. For example, we may want to print same text 10 times. In that case, we will need an integer variable to count number of iterations. This counter variable can be used in the loop condition to verify the number of repetitions are less than or equal to 10. Every repetition of the loop is called as an iteration. So if we want to print the text hello world 10 times, printing it first time is the first iteration. Printing it second time is the second iteration, and so on. At the end of each iteration, there may also be an iterator section. An iterator section can be used to perform some operations which are required to be done before evaluating condition for next iteration. If our program is trying to print the text hello world 10 times, then in each iteration, after displaying the text, we may want to increase the counter by 1.
This is how the loop condition will know how many times the code segment has been repeated already. So in this section, we have seen what is a loop. We also have seen what are some basic parts when it comes to coding the loop. Now let's move on to the next section. In this section, we are going to have a look at iteration statements. The iteration statements are the statements which can be used to program the loop. There are 4 keywords which can be used for this purpose. Those keywords are while, for, do while, and for each. Let's have a look at these keywords one by one. Let's begin with while keyword. The code snippet on this slide shows the program to print hello world 10 times. The initializer section is the part where variable index is declared. It has also been initialized with the value 0. This variable is then used in the loop condition. The syntax for starting loop is the loop keyword while followed by the condition inside parentheses. So here we are saying repeat while index is less than 10. After this condition, we can add the code that we want to repeat inside the curly brackets. The code inside the curly brackets is called as body of the loop. Let's say if the loop body contains a single line of code, then the curly brackets can be avoided. Now let's see how this loop executes. Firstly, the variable is initialized, and then the control comes to next line where condition is evaluated. If the condition is true, then the control starts executing the body of loop. The loop body may contain any statements like arithmetic statements, string operations, or method calls. At the end of iteration, the index is incremented by 1. We have used a plus symbol here. This symbol is called as post increment operator. It increases the value of its operand by 1. After the iterator statement, the condition is evaluated again, and this goes on until the condition is evaluated to be false. When the condition is false, the loop terminates and the control executes the next statement after the loop. The initializer section here is very obvious. There is no chance of missing it because it declares the variable that we should use in the loop condition. But if you are a beginner, then there is a slight chance that you may miss the iterator section. So in case of this program, what will happen if the iterator section is missed? If the counter is not incremented at the end of every iteration, then loop condition will never know how many times the code has been repeated. And this will result in condition always being true, regardless of how many repetitions have been done already, because the counter will always be 0, and this will cause an infinite loop. Now, let's talk about the for keyword. If we use for keyword, then all the 3 sections, initializer, condition, and iterator, can be specified in the single line as shown here. After this, the loop body can be specified within curly brackets. If the loop body contains a single line of code, then the curly brackets are not required, but it is better to use curly brackets to explicitly mark the boundaries. Let's now see how the code is executed. Firstly, the initializer section is executed. After the initializer, the condition is evaluated. If the condition is true, then the code block inside the curly brackets is executed. Once a single iteration is done, the control goes to iterator part of the for statement. In this code snippet, the iterator part increases the value of index by 1 using post increment operator. After iterator statement, the condition is evaluated again, and the flow continues like this until the condition is false. When the condition is false, the next statement after the loop is executed. The important point to note here is all the 3 parts that we specify in the for statement are optional. So initializer, condition, and iterator are optional and they can be empty. For that matter, we can just specify 2 semicolon inside the parenthesis after for keyword. This would mean that the loop is infinite. There is no condition to break the loop and the loop will execute endlessly. Till now, we have seen the code examples where the iterator section increments the value of loop variable by 1 using post increment operator. Similarly, there is a post decrement operator as well. It is represented by double minus signs. It can be used to decrement the value of its operand by 1. Instead of increment or decrement, an iterator section may contain only assignment statement. This assignment statement will just assign some value to the variable which is used in condition. Okay, let's move on to the next type of loop. The next type of loop is a do-while loop. This loop is little odd as compared to previous 2 loops. The syntax of do-while loop is very similar to syntax of while loop. Before beginning the body of loop, there is one initializer section to initialize the index variable. And then there is a while keyword followed by the condition. But the difference here is the body of loop comes before the condition. the body of loop begins with the do keyword. Do keyword is followed by curly brackets, and inside these curly brackets we can specify the statements that we want to repeat. After the curly brackets, we can use while keyword followed by condition inside the parenthesis as shown here. Here, the flow of execution is bit different. After initializer, the body of loop is executed even before evaluating the condition. That's why this loop is bit odd. The condition is evaluated after the code block has executed once. If this condition is found to be true, then the loop body executes again. This flow goes on like this until the while condition is false. Let's compare the do while loop with the while loop. Let's say we initialize this index variable to a value 10. In such case, the loop condition will evaluate to false. In case of while loop, the loop body will not be executed at all because the condition is false. On the other hand, the do while loop evaluates the condition at the end after the first iteration is done. That means the hello world text would be displayed once and then the condition would be evaluated. And as the condition would evaluate to false, the loop body will not execute again and the loop will terminate. That's why do while loop is bit odd. The while loop and the for loop evaluate the condition. That means they will repeat set of instructions 0 or more times. On the other hand, the do while loop will execute the body one or more times. I hope the difference is clear now. Let's move on to the next type of loop. The next type of iteration statement is for each loop. The for each keyword provides an easy way to iterate over a collection. A collection is an object which stores multiple values. So for demonstrating for each loop usage, we have created an integer array here. This first line is the syntax to create an integer array. Int keyword is followed by square brackets, followed by the variable name, and variable name is followed by an assignment operator. The square brackets specified on the right side of assignment operator contains a number. This number specifies how many values this array can hold. In our case, we want to store 5 values in this array, and that's why we have specified the number 5 inside the square bracket. After the square brackets, an array can be initialized by specifying 5 values inside curly brackets. We have not covered the collection data types yet in our course. We will try to cover collections in future chapter. Okay, so we have declared an array. Now, because array is a collection type, we can use it inside the for each statement. The for each statement is easy to read. It literally says for each number in array. Here, the number is a variable which represents a single value from the collection. As number is a variable, it will also need a data type. We can use var here and let the compiler deduce the data type automatically from the collection, or else we can explicitly specify the data type here. So here, in this case, we could have used int instead of var, and the program would still work as expected. Inside the body of for each loop, we can add one or more statements. If for each loop contains a single statement in the loop body, the curly brackets here are not mandatory, but it is better to add curly brackets to explicitly mark the boundaries. As you can see here, we have not used any iterator or initializer as such. The only requirement for using for each statement is there should be a collection object, and the data type of that collection object should have implemented getEnumerator method. We will talk more about this method and for each loop when we discuss about collections. This concludes the theory part of the chapter. Now let's use this theory to write some code. Let's open the Visual Studio and create a console application. In the last chapter, we wrote a program to identify if given input integer is even or odd. I am going to write that program again. So a console.write to ask for user input, and then console.readline to read the user input, and convert.toInt32 to convert that input value into integer. After this, we can use a ternary operator to check if remainder after dividing the number by 2 is equal to 0 or not. If it is 0, then ternary operator would return text even. If it is not, then the ternary operator would return the text odd. Next, we can use the outcome of the ternary operator into a console.writeLine statement to print the output of the program. It seems our program is ready, but if we run the program now, the program will only work for single input and then program will exit. If we want to try any other number, we will have to run the program again. Let's try to modify this program to keep it running until user wants it to run. The idea here is to ask user if user wish to try another number. If user enters y, then the program will keep running. In this case, our condition will be based on a single character. So in the initializer, let's declare a character variable keep running and assign a value y to it. Why did we assign this value to the variable? This is because when the program runs, we want it to start with asking for integer input. It need not ask whether user wants to try another number. So after initializer, we need to set the loop condition. Here we will use while loop. In the loop condition, we can say that while keep running is equal to y. run the body of the loop. Here we are using double equal to sign, which is equality comparison operator. So we have initializer ready, we also have set the condition, and we have an empty body in the loop. So I will move rest of the statements inside the body of loop. Now the last part is iterator section. Here let's add a console.write to ask the question if user wants to try any other input. After displaying the text, let's add console.read key, which reads a single character input and it does not wait for user to press the enter key. The return value of console.read key is console key info object. This object has a property keychar. This property returns the input character. So we can assign input value.keychar to keep running variable. Now iterator section is also done. After the loop body, we can add a goodbye message. So let's add a console.write line to display have a nice day text. This is to confirm that program is exiting. This text will be printed if user enters any value other than y. Also, in the iterator section, we have used console.write. And as we know, console.write does not actually print a new line. Let me add a console.write line to ensure that subsequent text is printed on the next line. It seems our program is ready. Now is the time to verify if it runs as expected. So let's run the program. We can enter 10 now, and the program correctly prints that the number is even. It also asks if we want to try any other number. Let's press lowercase y here and the program will ask for another number. We can try 13 and it correctly prints that the number is odd. Next time, enter any value other than y and the program will exit. While exiting, it displays the goodbye text to confirm that program is exiting. So it seems like our program is working as expected. But this program has a flaw. The loop condition only checks for lowercase y. What if user enters uppercase y? Let's run the program again and this time try any random input. And when program asks if we want to try any other number, let's enter uppercase y. Surprisingly, the program exits. Why did it exit? A character is internally an integer value. A lowercase letter has different integer value than the corresponding uppercase letter. That means the value of lowercase y is not equal to the value of uppercase y. Now what can we do to fix this behavior? We can modify the loop condition and use a conditional or operator here. So let's modify this condition and let's say until keep running is equal to lowercase y or keep running is equal to uppercase y. We want loop to run. After this modification, let's run the program again. Try any random input. And when the program asks if we want to try any other number, let's enter uppercase y. In this case, program doesn't exit. It asks for another number. So seems like our fix is working.
Now let's see how this same code can be converted to use a for loop instead of a while loop. In the for statement, the initializer, the condition and the iterator can be written on the same line. In our case, let's add initializer and the condition in the for statement. Now the iterator section is a bit tricky. We have an option to move this line where we set keep running variable to the input value in the iterator section. But in my opinion, that may reduce readability of the code. So let's keep this iterator part empty. We already know that all the three parts of for statement are optional. That's why the for statement will allow this syntax. Just to clarify, we have not skipped the iterator section. In our case, the iterator still exists, but it is inside the body of the loop. Let's try to run the program. Enter, let's say 10 as input. The program correctly displays that the number is even. And then it asks if we want to try another input. Let's enter y and the program will ask for next input. Now let's say we enter 13 and program will correctly print that it is an odd number. And after that, let's enter n to exit the program. It seems our loop is working as expected. Now let's try to convert the same program to use a do while statement. Firstly, let's move this initializer at the beginning. As we know, the do while statement executes the loop one or more times. That's why we don't need to initialize keep running variable to value y. This is because when the loop executes for the first time, it will not check if the keep running variable is equal to y or not. It will first ask for the input number and then the while condition will be executed. So our initializer is done. Now instead of for, let's type the keyword do and copy this condition from the for statement and let's go to the ending curly bracket of the loop. Here we can type while keyword and then we can specify the same condition inside the parenthesis. The closing parenthesis will be followed by a semicolon and that's it. The rest of code can stay same as it was before. Now, if we run the program, it should produce the same outcome as expected. So in this section, we have used different kinds of iteration statements to create the loops. I hope this was helpful for you to understand the differences between these three types of loops. Okay, let's move on to the next example. In previous code example, we have used single loop. We can also nest the loops. This means that one loop can be present inside body of another loop. For demonstrating that, let's try another problem statement. When we were in school, we have studied multiplication tables. Let's write a program to print multiplication tables for numbers from 11 to 20. We will display the multiplication tables in the format as shown here. Here, the tables are shown side by side, but in our code, they will be printed one after the other to keep the things simple. So for our program, each number from 11 to 20 must be multiplied by each number from 1 to 10. We can achieve this by using nested loops. We can have an outer loop variable which represents the current multiplication table, and then we can have an inner loop variable which represents multiplier from 1 to 10. Let's begin with for statement. In the initializer section, let's declare a variable index. Let's initialize its value to 11. And in the condition section, we can specify that we want to run this loop until the value of this index variable is less than or equal to 20. In the iterator section, we can increment the value of this index variable by 1. So this is our outer loop. Inside this loop, we can add some marker statements to represent beginning of the multiplication table for a number. So let's add 3 console.writeLine statements as shown here. The middle statement displays the header for the current table. Next, we need to multiply the value of this index by each number from 1 to 10. So begin another loop. In this nested for loop, we can begin with initializer section. Let's declare a variable called as multiplier, which is initialized to value 1. And here we can specify the condition that this nested loop should continue for all the values of multiplier until multiplier is less than or equal to 10. And finally, in the iterator section, increment this multiplier by 1. Okay, so we have defined 2 loops, one inside the other. Every iteration of outer loop will execute all the iterations of inner loop. That means for 11, inner loop will execute 10 times. For 12 as well, the inner loop will execute for 10 times, and so on. Every iteration of inner loop will have both the values, index and multiplier. We can multiply those 2 numbers and then display the result in the intended format like this. Here, we are printing the value of index, the value of multiplier, followed by the result of multiplication. Now, if we run the program, we can see that the multiplication chart is printed one after the other. I hope this demo was useful to understand how nested loops work. Although this code example had a single level of nesting, technically any number of loops can be nested, one inside the body of the other loop. Okay, let's move on.
Jump statements are the statements which unconditionally transfer the control from one place to another. We are going to have a look at 4 keywords in this section. Let's start with keyword goto. As the name suggests, it instructs the control to go to a specific label in the code. A label is just an identifier followed by a colon as shown on this slide. Here, the code snippet is showing the usage of goto statement. It is trying to print the text hello world 10 times using goto statement. In this code snippet, there is initializer which initializes the index variable to 0, and then there is a label of name repeat underscore label. The label is followed by the colon character. After the label, there is a single statement to print hello world. And then there is an iterator statement to increase the value of index variable. On the next line, the conditional statements verifies if the value of index variable is less than 10. And if it is, then the control is transferred to the repeat label using goto statement. The syntax of goto statement is very simple. The keyword goto followed by the label name, repeat underscore label. After the label name, there is a semicolon to end the statement. In this code snippet, the goto statement produces the same effect as that of loops. In general, the code which uses goto statement may not be easy to read, and that's why it is general practice to avoid usage of goto statements. In all the cases, the code which uses goto statement can be rewritten without using the goto statements. For example, in this code snippet, we could have used any iteration statement to produce the same outcome. Let's now move on to the next keyword. The next keyword is break. We already have used this break keyword inside the switch statement. In the switch statements, this keyword was marking end of section for a particular case. In loops, the break keyword can be used to terminate the closest loop. Every loop statement contains condition. If that condition is false, the loop is terminated. But sometimes we may want to terminate the loop even before all the iterations are done. This is because the code might already have got the required result. In such cases, we can use break statement to terminate the loop. It will only terminate the closest loop. So let's say the loops are nested and one loop is inside the body of another loop statement and the break statement is inside the inner loop. Then the break statement will terminate only the nested loop. The outer loop would still continue executing. Here, the code snippet shows the code which terminates the loop when index is equal to 5. This means the loop will display the text hello world 5 times. In the 6th iteration, index will be equal to 5, and that's why the if condition will become true. And in that case, the loop will be terminated because of the break statement. I hope this clarifies the meaning of break statement. Let's now move on to the next keyword. The next keyword is continue keyword. This keyword is used inside the iteration statements. When the continue statement is executed, all the subsequent code statements which come after the continue statement are skipped in that particular iteration, and the loop begins next iteration. The code snippet shown here prints hello world in first 5 iterations. In the 6th iteration, the index will be equal to 5, and hence the continue statement will execute. This will cause skipping of rest of the block of code. This means the text hello world will not be displayed when index is equal to 5. Let's move on to the last keyword of this section, and the keyword is return. In C#, code inside a class is organized into multiple methods. Each method may call another method. So there can be first method which calls second method, and this second method may call some other method, and so on. The return statement terminates the closest method and returns the control to its caller. If the return type of a method is void, then the syntax is just the return keyword followed by the semicolon. But if the return type of a method is not void, and if the method is supposed to return value of any specific type, in that case, the return keyword will be followed by a variable of that type, or it can also be followed by a value which can be assigned to that particular type. We will again discuss this keyword when we talk about methods in coming chapters. Let's try to understand this code snippet a bit. Here, we have declared a method with name display hello world. This method contains a loop. Inside the body of the loop, there is a condition to check if index is equal to 5. If the index is found to be 5, then the return statement will be executed. This method is called from the top level statement. So, when this code is executed, the text hello world will be printed for 5 times. In the 6th iteration, the index will be equal to 5, and the control will return to the caller. This also means that the loop will be terminated. Okay, let's move on.
Now again, it is time for us to open Visual Studio and try these jump statements in our code. Let's write a program to check if a string is palindrome or not. A palindrome is a word, number, phrase, or other sequence of characters which reads the same backward as well as forward. For example, words like radar, level, civic remain same even if the order of letters is reversed. Thus, they are palindrome. For identifying if a string is palindrome or not, we can write a loop. We would need 2 variables, one moving forward from beginning towards the end of the string, while the other moving backward from the end of the string towards the beginning. In every iteration of the loop, we can check if the characters pointed by the 2 pointers are equal or not. If the characters match, then the loop will continue. This comparison will go on until the 2 pointers cross each other. There is also one more case in which the loop may terminate. If the 2 characters pointed by forward pointer and the backward pointers are not matching, then we can terminate the loop by using break statement. Let's begin writing our program. Let's ask user to enter a string. Then we can use console.readLine to read the input. The user input may contain uppercase as well as lowercase characters. We will use .toLower method on the input string variable, which will transform all the uppercase alphabets to lowercase. This step will help us avoid some additional conditions while comparing the characters. A string is basically a sequence of characters. The first character of the string is present at index 0. A string variable has a length property which represents the length of given string. The number string.length -1 represents the index of last character in that particular string. Now we can declare 2 int variables, forward and backward. The forward can be initialized to 0 and backward can be initialized to input string.length -1. We are going to refer these variables as pointers. This is because each one of them is pointing to a specific character in the string. We could have specified both these variables in the Initializer section of the for statement. In that case, those 2 statements would have been separated by comma, but for the sake of this demo, we will add an empty Initializer section in the for statement. In the condition section, we can specify that the forward pointer should be less than or equal to backward pointer. If forward pointer is greater than backward pointer, this means the 2 pointers have crossed each other, and that's why the loop should be terminated. Now in the Iterator section of the statement, increment the forward pointer by using post increment operator and decrement the backward pointer by using post decrement operator. These 2 statements can be separated by comma as shown here.
Inside the body of loop, we can compare the two characters pointed by these two pointers using the if statement. If those values do not match, then we can write a break statement to terminate the loop. Otherwise, the loop will continue to execute until the loop condition is true. The loop may get terminated because of two possibilities. Either the string is palindrome, in which case forward pointer will be greater than the backward pointer, while on the other hand, if the string is not palindrome, then the forward pointer wouldn't have crossed the backward pointer. After the loop, we can use ternary operator to see if forward pointer is greater than the backward pointer. If it is the case, then the string is palindrome. Otherwise, the string is not palindrome. So we can use a ternary operator like this, which returns a string value. This outcome of ternary operator can be then used in a console.writeline to display the outcome of the program. Okay, it seems our program is ready. Let's try to run the program. First, let's try with a string which is palindrome, and the program correctly identifies that the string is palindrome. We can run the program again, and this time we can input a string which is not palindrome. This time also program correctly prints the output. So in this code example, we have seen how to specify multiple statements in the initializer and iterator sections of the for loop. I hope this example was also helpful to understand how the break statement works. Now, let's move on to the next example. This time, we are going to write a program which allows user to input an integer value. The program will check if the number is prime or not. If the input number is not prime, then the program will ask user to input the next number. That means user will exit the program only if the input number is prime. So let's begin the program by asking user to input an integer value, and then we will use console.readline to read the input. After that, convert.toInt32 can be used to convert the input into integer. Now we have the input number. Next, we need to check if this number is prime or not. A number is prime if it is divisible by 1 or the number itself. That means if the number has any other divisor, it would not be prime. So we can take a loop here. The loop will range from all the values starting from 2 until number -1. And if any value divides the input number, then the input number is not prime. So let's add a for statement in our code. In the initializer section, let's take variable I and initialize it to 2. In the condition section, let's write a condition that I should be less than the number. Remember that condition is evaluated before executing the body of loop. So the body of loop will be executed only until I is equal to number -1. When I is equal to number, the loop will terminate. In iterator section, we can increment I by 1 using a post increment operator. Inside the body of loop, we can use modulus operator to check if the remainder is 0 after dividing the number by I. If the remainder is 0, it means the number is divisible by I. That means the number is not prime. And in that case, we don't need to continue the loop. We can add a break statement inside this if block as shown here. If the remainder is not 0, then this loop will keep executing. Outside this loop, ternary operator can check if I is equal to number. But wait, here we are getting an error. If I hover over the red line, I can see the details of the error. It says that variable I does not exist in the current context. We have not discussed variable scopes yet, but the variable scope is the area in which the variable can be accessed. We will discuss more about scopes in some future chapter. For simplicity, we can assume that the scope begins with opening curly bracket and it ends with a closing curly bracket. So if we declare a variable, it would be accessible only before the next immediate closing curly bracket is encountered. So here we got to know that if we declare a variable in the initializer section of the for statement, it cannot be used outside the body of loop. The body of the for loop is the only allowed context or scope for using that variable. So let's change our loop a bit. Let's move this initializer before the loop. So now the variable declaration of I is a top level statement. That means this variable will be accessible from both inside as well as outside of the loop. Okay, now coming back to where I was. We can add a ternary operator here to check if I is equal to number. If it is, that means all the iterations of the loop were executed, no other divisor was found. So the number is prime. And that's why the ternary operator would return the text prime in that case. If this condition is false, that means other divisor was found and the ternary operator will return not prime text. Now we can add a console.writeline to print the end result on the console. We know that this program handles one input at a time. The program will exit after checking if a number is prime or not. We will need to run this program again for trying any other input. So let's modify our program and use a goto statement this time. Let's add an if statement like this. Here we are checking that the number should not be equal to I. This condition will be true when the number is not prime.
Now inside this if block, we can use a goto keyword followed by a label name, beginning. Currently we don't have any labels inside our code, so we will have to declare a label with name beginning. For that, let's go to the top of the program and then type the identifier name beginning followed by the colon character. Now our program is complete. Let's try to run the program. We can try any numbers as input. If the input number is not prime, the program will keep asking for next number. If the input number is prime, then the program will exit. In this code example, we have seen how to use goto statement. Again, we could have used iteration statement to produce the same outcome as goto statement. In my opinion, it is always better to avoid goto statement as it reduces the readability of the code. Okay, let's move on to the next example. In the next code example, we will try to write another program to display sum of all those numbers between 1 and 200 which are divisible by 8. So let's declare a sum variable and initialize it to 0. Then we can write a for statement, and in the initializer we can take a variable number and set it to 1. Until this number is less than or equal to 200, increase the number by 1. Okay, our loop definition is ready. If the number is divisible by 8, then we need to add it to some variable. So we can use an if statement. The condition for if statement can use a modulus operator to check if the number is divisible by 8. When the number is divisible by 8, the remainder would be equal to 0 and hence the condition will be true. Inside this if block, we can say that sum is equal to sum plus current number. If the current number is not divisible by 8, then the remainder would not be equal to 0 and the if condition will be false, and that's why if block will not execute. Our program is ready. We can run the program and see the outcome. Now coming back to the code, the loop was keeping all the numbers which were not divisible by 8. Let's modify this program to understand how the continue work. For that, we will have to change the if condition. The new condition should check that remainder should not be equal to 0. When this condition is true, we want loop to skip all the rest of the statements in the body of loop. So we will add a continue statement here, followed by a semicolon. If this condition is false, that means the number will be divisible by 8, so the iteration will not be skipped. In that case, outside the if block, but inside the for loop, we can add a statement to add the current number to current value of sum. Okay, our program is ready. Let's run the program and we can see that the same outcome is produced by the program. This was our last code example. I hope these code examples were helpful. Now let's move on to the final section of this chapter. This section shows exercises that you should try on your own. In the first exercise, ask user for integer input and then calculate the factorial of that number. A factorial of input number can be calculated by multiplying all the positive numbers which are less than or equal to the input number. In the second exercise, allow user to provide as many numbers as user wants. Once user is done providing the numbers, print the smallest number and the biggest number. In the third exercise, ask user to input an integer, then reverse the digit of that number. For example, if user enters 1, 2, 3, then the output should be 3, 2, 1. Here, we do not need to perform string operations. Try to convert the input number to integer and then use modulus operator and division operator. In fourth exercise, write a program to print the sum of all those integers which are between 100 and 200 and which are also divisible by 6. Let me know the outcome in the comments. Alright guys, that's it from this chapter.
We have covered various data types in chapter 4, but in subsequent chapters I tried to use numeric data types to explain iteration statements and conditional statements. I think it is right time for us to take a pause and then have a closer look at the string data type. In this chapter, we will begin our discussion with some fundamentals of the string type. Later, we are going to have a look at some operations that can be performed on the variables of string type. So in that section, we will have a look at how to compare the strings, how to split the strings, how to concatenate the strings, how to dynamically form the contents of the strings, etc. While performing many of those operations, we need to pass a culture info object. That's why we will also discuss few things about it. And finally, we will discuss one important question. When should we prefer string builder type over string type? I hope you watch this video till the end because, like previous chapters, there will be some exercises at the end of this chapter too. You can try those exercises on your own to make sure that you have grasped all the contents from this chapter. So let's get started.
Let's begin our discussion with a simple question. What is a string? We know few things about string type already. We have seen that a string is a reference type, so its value is stored on a heap. Similarly, we also have discussed about how to declare string variable. A sample declaration is shown here. It begins with string keyword followed by the variable name. The variable name can optionally be followed by an assignment operator followed by a string value inside double quotes. The string value inside the double quotes is sometimes called as string literal. Now let's see what is the technical definition of the string. According to technical definition, a string is a read-only sequence of characters. Here, the word read-only means that the characters in the string are read-only. We cannot modify them. There is one more important thing to highlight. In some programming languages, end of a string is marked by a null character. In C#, strings do not terminate by null character. In fact, a string can contain as many null characters as we want. Now let's see what are various ways to declare a string variable. The first line shows declaration without initialization. Here we have declared the variable, but we have not assigned any value to it. In this case, the default value is assigned to the variable, and the default value for string type is null. On the second line, we have declared a variable and we have explicitly assigned a null to it. Another way to initialize a string is using string.empty constant. As shown here, we can declare a string variable and we can assign string.empty value to it. Empty strings are different from nulls. When a string variable is assigned null, it means that the string variable is not pointing to any object on the heap. But when a string variable is assigned with a value string.empty, that means an object is created on the heap which doesn't contain any characters, and the string variable is pointing to that object. This string.empty constant is equivalent to specifying opening and closing double quote without specifying any characters between them. You also might have noticed one other important thing. Sometimes the data type name is beginning with an uppercase s, while in some other cases the type name is beginning with lowercase s. An obvious question here is, what is the difference between these two types? Internally, both of these types are actually pointing to the same implementation. In .NET, string type is implemented using string class. The class name is string with an uppercase s. This class is defined inside system namespace. So when we use the data type name with an uppercase s, we actually mean to use that particular class. And for using that class, we also need to make sure that we have added a using statement to import the system namespace. C# has aliased the class system.string with the keyword string. The keyword actually begins with lowercase s character. So in a nutshell, the class name begins with uppercase s while the keyword begins with lowercase s. Generally, it is recommended to use string keyword rather than the string class. Why? Because if you want to use string class, then you will have to add an additional using statement at the top to import the system namespace. But if you want to use the string keyword, you will not need the using statement. I hope the difference is clear now. Let's move on to the next way of declaring the string. We can also declare a string variable and initialize it with a string literal as shown here. Instead of using string keyword, we can use var keyword. In that case, the syntax is var keyword followed by the variable name followed by assignment operator followed by the string literal. When we use var keyword, it is mandatory that we initialize the variable with some value. This is because when we use var, the compiler needs to deduce the data type of that variable based on the expression on the right hand side of the assignment operator. If we use var keyword to declare a variable and we do not specify assignment operator and the expression on the right hand side, it results in compile time error. As we have seen in the technical definition, string basically can contain 0 or more characters. So we can create the string variable from the character array. In this code snippet, on last 2 lines, we have created a character array which contains 3 characters. And then on the last line, we have used new keyword to create the new string object and we have passed that character array as input. This new keyword is generally used to instantiate a class. We have not seen the details about this new keyword and we also have not discussed about the classes yet. So I will not discuss more about this particular method in this chapter. I hope you know various ways to declare strings now. We know that the string value is specified within double quotes. But what if we want to include double quotes inside the string? There is one example shown here. If we include double quote like this, then the compiler will give an error. It will say that the string literal is not well formed. So what can we do to include double quotes inside the string? Escape sequence is the answer. Escape sequence is basically a sequence of characters which does not represent itself, but actually that sequence is transformed into a single character. In C#, the escape sequence starts with a backslash character. So as shown here,
If we want to include double quotes inside the string, then we can use this particular escape sequence, which contains two characters, backslash and a double quote. These two characters will be converted into a single character inside the string, a double quote character. Similarly, if we want to include a single quote, then a backslash and a single quote is the escape sequence for it. Let's say if we want to add a null character in the string, then we can use backslash followed by a 0. These two characters will be converted into a null. Similarly, here we have shown some other important escape sequences. Three important escape sequences are /r, /n and /t. /r is for carriage return, /n is for new line feed, and /t is for tab character. If we use /r and /n, then the cursor will move to the next line for outputting the subsequent characters in the string. If we use /t, then it would basically render a tab character. Now, if we are using backslash for escape sequences, how should we include the backslash itself in the string? For including the backslash, it should also be escaped with another backslash. So two backslashes will be converted into a single backslash. As we know, in the .NET, the characters are represented by their Unicode values. The Unicode value can be a 16-bit value or a 32-bit value. Backslash and lowercase u combination must be followed by a 16-bit Unicode value. All of those letters will be converted to a single letter while outputting the data. On the other hand, backslash and uppercase u must be followed by a 32-bit Unicode value. All of those will be combined into a single character while outputting the string contents. I know this concept of escape sequences might sound confusing to some of us. Please bear with me until we complete the theory part of this chapter. Once the theory part is done, we will start with code examples where we will try to use these escape sequences to understand them better. We already have seen that the value specified within the double quotes is called as a string literal. C# supports two types of string literals, regular string literals and verbatim string literals. A regular string literal consists of one or more characters. It may contain simple characters as well as escape sequences. It may also contain hexadecimals and Unicode escape sequences. Before looking at what is verbatim string literals, let's understand what the word means. The word verbatim literally means in exactly same words as used originally. The verbatim string literal has @ prefix. The verbatim string literal also contains string value inside the double quotes. All the characters inside the double quotes are represented as is. A verbatim string literal will not process any escape sequence that appears between the delimiters of the string value. The only exception to this is double quote character. If we want to use double quote character inside verbatim string literal, then we can use two double quotes. Two double quotes will be converted into a single double quote. A verbatim string literal may also span over multiple lines. Actually, after the compilation, verbatim string literals are converted into a regular string literals. But then the obvious question is, why should we use verbatim string literals? In my opinion, sometimes verbatim string literal usage helps to make the code more readable, and that's why they should be used. Now, let's discuss some commonly used string operations. Let's have a look at how to access individual characters from a given string. As we know, string is a read-only sequence of characters. It can contain 0 or more characters. So, it is a collection. And because it is a collection, we can use a Foreach statement to access individual characters. The variable declared inside the Foreach statement gets initialized with a single character from the string, and then that variable can be used for further processing. Once a particular iteration is over, that variable will be initialized with the next character from the given string. There is also one more way to access individual characters from a string. We can use integer index. In C#, the first character in the string is present at index 0, the second character is present at index 1, and so on. So if string contains 5 characters, then the last character will be present at index 4. So if we generalize this, the index of last character in the string can be found out by applying a formula string.length -1. So using this information, we can write any iteration statement to loop over string characters from index 0 until index is less than string.length. Here in this code snippet, we have used a for statement. In the initializer section, we have initialized index to 0. And in the condition section, we have specified a condition that index should be less than string.length. After every iteration, we want index to be incremented by 1. Then we can specify the index inside the square brackets to get the individual characters from the string. There is one point to note here. We cannot really modify individual characters from the string because string is a read-only sequence of characters. Now let's have a look at some other commonly used string operations. The code snippet here shows equality comparisons between two string variables. In order to check if the values of two string variables are equal, we can use equality comparison operator as shown here. For equality checks, we can use double equal to sign. If you remember, while talking about conditional statements, I told that double equal to operator behaves differently for reference types. For reference types, the double equal to sign compares references rather than comparing the actual values. This double equal to sign is overloaded in the string class to check for values rather than checking for references. And that's why this operator can be used to check if the values pointed by two string variables are equal or not. For the same reasons, we can use exclamation mark followed by equal to sign, the inequality operator, for asserting that two values are not equal. In addition to these two operators, the string class also provides one more method, equals, which can be used for checking if two values are equal or not. The syntax for calling equals method is first variable followed by dot followed by method name, and then inside the parentheses we can specify another variable or a value or an expression. So we have seen how to compare two string values for equality and inequality. Before we move any further, let's have a look at another important concept. As we know, string is a reference type. So a string object is created on the heap and its reference is stored on the stack. So when we declare two string variables with exact same values, then the compiler creates only one object on the heap. To better understand this, let's say we have two variables, x and y. Both are assigned with the same value. Also note that this value is known at the compile time. As the compiler knows that both of these variables are pointing to the same value, it will generate the code in such a way that when we run the program, only one object containing this value will be created on the heap. And then both of these variables will point to the same object, as shown in this diagram. This feature is called as string interning. String interning itself is a separate topic. I will not go into further details here. Then why did I bring it up here for the discussion? Because the string class also provides reference equals method, which needs two parameters. Both of those parameters must be of string type. This method returns true if both of the parameters which were passed to the method are pointing to the same object. This means that both of those variables should have the same reference. The code snippet on this slide shows how to use reference equals method. First, the code initializes two variables, first and second, with the same value. And then it calls string.reference equals to check if both of these variables are pointing to the same object. Because of string interning, they will point to the same object. And that's why the reference equals method will return true and if block will be executed. If we want to avoid string interning, then we can use string.copy method to assign a value from one string variable to other string variable. So in this code snippet, we have declared a third variable which is also assigned with the same value. This time we have used string.copy method and we have passed the variable first. And after this, we have added code to check if the first variable and the third variable are pointing to the same object. Because string.copy prevents string interning, the reference equals method will return false. And that's why if block will not be executed. Instead, the else block will be executed, which will print that first and third variable are not pointing to the same object. I hope the concept of reference equality is clear now. Let's move on. String formatting is another frequently used string operation. A format string is a string whose contents are determined dynamically at the runtime. There are two ways to perform string formatting: composite formatting and string interpolation. In composite formatting, string literal can contain some placeholders. Each placeholder is basically a number specified within the curly brackets. When the program is running, the placeholders are replaced by the actual values of the variables. There are many methods which support composite formatting. String.format is one of the common methods that is used for this purpose. This method takes variable number of input parameters. The first parameter must be a string literal containing placeholders. And the subsequent parameters must be the variables whose values will be used to replace the placeholders at the runtime. The numbers that are used in the placeholders begin with 0. So the first placeholder will be 0 inside curly brackets, second placeholder will be 1 within curly brackets, and so on. The first parameter after the string literal will replace the first placeholder. The second parameter after the string literal will replace the second placeholder, and so on. In this code snippet, the first placeholder, which is 0 inside the curly bracket, will be replaced by the value of variable name. Another way to format string is interpolation. If we want to use interpolation, then the string literal must be prefixed with a $sign. Then the string literal can contain expressions inside the curly brackets. When the program executes, the curly bracket and the expression is replaced by the actual value of the expression. For example, the last line in this code snippet is a console.write line to print some data on the console. While printing the data on the console, instead of using composite formatting, it uses string interpolation. And that's why the string literal is prefixed with $sign. In the string literal, the variable is specified inside the curly brackets. When we run the program, the curly bracket and the variable itself will be replaced by the actual value of the variable. There are many other operations that can be performed on the strings. We can check if the string begins with a specific pattern or if it ends with a specific pattern. We can also check if string contains another string. Or else sometimes we may want to modify the strings. We may want to convert all the characters from the string to uppercase, or otherwise we may want to convert all the characters from a given string to lowercase. Sometimes we may want to split a given string into multiple strings, while some other times we may want to concatenate multiple strings into a single one. Now that we know some basic concepts, it is right time for us to open Visual Studio and try coding some string operations. In the first code example, let's try to create a program to print string in reverse order. Let's begin with console.readLine to read the input string. Here, we do not want to store the reversed string in a variable. So, we can just access individual characters starting from the last character of the string until the first character and then print them. So, let's initialize loop variable index to string.length -1. Then we can write a while statement and we can specify condition that until this index is greater than or equal to 0, we want loop to continue. Inside the while block, we can access individual characters and display it on the console using console.write method. We have used console.write method here because we want all the characters to be printed on the same line, one after the other. After this, let's decrement the value of index variable by 1. Also, just before the loop begins, let's display a message stating that the output will be printed on the next line. Now, if we run the program, we can see that the strings are reversed. But when the program starts, the program does not display any text asking for input. It just waits until user provides input. It may be confusing sometimes, and hence it is better to add a console.write to display a message asking for user input. Now if we run the program again, we can see the instruction explicitly asking us to provide the input. If I provide any input here, the program will print the string in the reversed order. Okay, let's move on to the next example. Now, let's write another program which takes first name and last name as inputs. So, two console.read lines. First one reading the first name and the next one is reading the last name. While providing the inputs, user may enter white spaces before the names or after the names. And currently we are not interested in those leading and trailing white spaces. So, we can use trim method to remove leading and trailing white spaces from a variable. If we want to remove only leading white spaces, then we can use trim start method. On the other hand, if we want to remove only trailing white spaces, then we can use trim end method. The syntax is similar. Trim method also provides another overload. We can pass the character that we want to trim. So instead of white space, we can remove any leading and trailing characters by using trim methods. Okay, now let's try to concatenate first name and last name. Let's use string interpolation for that. The string literal will begin with a $sign and then inside the double quotes, the expressions first name and last name will be present inside the curly brackets. We can also use two upper and two lower methods to modify the string contents. This method will return a string with all the characters converted to uppercase and lowercase respectively. Let's run the program, provide a sample input, and we can see that we are getting the expected outcomes. Now let's come back to the code. String class also provides two methods, starts with and ends with. These two methods can also be used to verify if the strings are beginning or ending with a specific pattern of characters. We can use a method starts with to check if a given string begins with a specific character or pattern of characters. Here, we can check if the first name is starting with white space character. If it is, then we are calling the trim start method to remove all the leading white spaces. Similarly, there is another method ends with. This method can be used to check if a given string ends with specific character or pattern of characters. Let's add another if block to check if the last name is ending with white space character. If it is, then we can call trim end method to remove all the trailing white spaces. Let's run the program. Enter a lot of leading and trailing spaces for every input.
we can see that the leading spaces are removed from the first name and the trailing spaces should also have been removed from the last name. The trailing white spaces from the first input and the leading white spaces from the second input are still present. Okay, now let's move on to the next program. Let's write another program which takes a string input. This time, a string input is basically a comma-separated string which contains multiple names. So, a console.readLine to read the input. And now, if the given string contains comma, then we want to split the names and we want to print all the individual names on new lines. We can use contains method. This contains method takes a character or a string as a parameter. It returns true if the specified pattern is present in the given string. Let's add a if block and then we can add a condition to check if the string contains comma, and if the comma is present then this condition would be true and the control will go inside the if block. Now we want to split this given input into multiple names. For this purpose we can use split method. Split method has multiple overloads. We are going to use the overload which takes a single character as input parameter. We will pass comma as the input parameter. This method returns string array. Now let's print all the items from this string array on the console. If we run the program, we can see that the program is printing individual names on the new line. But starting from second name, there are unwanted leading white spaces. So let's come back to the program and apply trim method. And now run the program again. This time, we are getting expected output and the leading white spaces are also gone. Now let's come back to program again. Instead of contains, we can also use another method, index of. It takes a character as input and returns an integer value. This method returns index of the first occurrence of a given character. If the returned value is -1, then the provided character was not found in the given string. Let's use index of method to find the index of comma and then modify our if condition to, and let's say that when the index of the comma is not -1, then we want to print all the individual names on new lines. Now we can run the program and we can see that it has produced the same output as before. Let's move on to the next code sample. Next, let's write a program to extract a substring. A substring basically means a sequence of characters that appear in the given string. So let's declare a string variable and assign some value to it. String class provides a method with the same name, substring. It has multiple overloads and we are going to use two variations of this method. In the first variation, we will call substring method with a single input parameter. We will pass an integer value. This integer value is basically an index. This single parameter overload means that we want all the characters from the string starting from the index that we have passed as input. So if I specify 4 here, then excluding first 4 characters, all the remaining characters would be returned by this substring operation. While calling the substring method second time, let's pass two parameters. The first parameter here is the index and second parameter is basically a length, and we are passing 4 and 8 values. Here we are instructing substring method to return 8 characters starting from character present at index 4. Now let's run the program and we can see that the program is producing the expected outcome. Okay, let's move on to the next topic. We know that a string is basically a read-only sequence of characters, but many times we may need to modify the string contents. One of the options for that is to convert the string into a character array, and for that we can use toCharArray method. Once the character array is created, we can then access individual characters from this array and then modify them. Here, we have created a character array and then we are setting the second character of the string to a white space. Note that this change will affect only the character array. It will not affect the original string. So let's display this array on the console. Let's run the program and we can see that there is a white space after the first character. Okay, let's now have a look at how escape sequences can be used. Let's create a string variable and try to assign a file path to it. If I use single slashes, I get the errors. So now I can apply escape sequence. For every backslash that I need in the string literal, I am going to prefix it with another backslash. And now the program is not complaining. This is basically an example of a regular string literal. Another option is we can use verbatim string literal. So the string literal will be prefixed with @character. And then inside the double quotes, we do not need to escape the backslashes. Now let's say we want to print a famous movie quote on the console. I hope you have watched Kung Fu Panda. It is one of my favorite movies. Let's use a quote from that movie. You can see that we want to display double quotes as well on the console. One option to achieve this is to use regular string literal and then escape the double quotes by using backslashes. And then let's print the value. Another way is to use verbatim string literal. Inside verbatim string literal, we need to escape the double quotes.
For every double quote that we want to show on console, we need to escape it with another double quote. So let's do that. Also, verbatim string literal can span over multiple lines, and all those new lines that I entered in the source code will also be printed on the console. Let's run the program now. We can see that the verbatim string is printed on multiple lines, while the regular string literal is printing the quote on the same line. Now, let's change our regular string literal to use a new line escape sequence. After every comma, let's add /n to add a new line. Now run the program again. We can see that even the regular string literal is printing the quote on multiple lines. I hope you found these code examples helpful. Let's move on.
Generally, the strings are compared to answer one of these two questions. The first question is, are these two strings equal? And let's say if you have multiple strings, then the another question may be, in what sort order these strings should be placed when sorting them? The answer to these two questions are not simple. There are many factors that affect string comparisons. First important factor is which kind of comparison do we want to apply. We can choose either ordinal or linguistic comparison. Let's try to understand what is ordinal comparison. If we choose this method, then code will check two strings character by character while comparing their respective integer values are compared. And hence, this type of comparison is case sensitive by default. So if words are same but the casing of letters is different, then the default ordinal comparison will return false. We can of course change this behavior and ask our code to use case insensitive comparison. If we enable case insensitive comparison, then the two strings will be equal as long as they contain same characters regardless of casing of letters. The string equality operator, string inequality operator, and string.equals method by default use ordinal case sensitive comparison. We already have seen how to use those operators in previous section. Now let's say if we want to apply case insensitive ordinal comparison, then what should we do? For that, many methods provide additional overloads for comparing strings. For example, string.equals method also has an additional overload which takes string comparison enum as a parameter. If we pass this additional parameter and if we set the value of string comparison parameter to string comparison dot ordinal ignore case, then case insensitive ordinal comparison will be performed. This code snippet shows the example of ordinal case insensitive comparison. As we can see, string.equals method has an additional parameter string comparison which is set to ordinal ignore case value. Let's have a look at what is linguistic comparison now. Linguistic comparisons are sometimes called as word sort order. In linguistic comparison, the strings are compared character by character. But while performing linguistic comparison, some non-alphanumeric characters may have certain weightage. For example, characters like underscores and hyphens may carry certain weightage in certain languages. And that's why if we try to apply sortings on set of strings, the sort order may change depending on the culture that was specified while comparing the strings. Also, sometimes a Unicode character may be a sequence of .NET char instances. So in such cases, the platform on which your code is running may play a vital role in the comparisons. For example, you may have written code to sort multiple strings using linguistic comparison. The outcome produced by this program on Windows may not match to the outcome produced by the same program on Linux. This is because in linguistic comparison, some rules are platform dependent. Let's now see what the word culture means. There are various spoken languages all around the world. The same data might get represented in different format in those languages. Even if there are two regions which talk the same language, the data representation in those two regions may be different. Locale is the term for the information which is required to represent data in different language and regional formats. For representing data in different regional formats and language formats, we may need various kinds of information. That information should include which character is used as currency symbol. It should also include which characters are used as decimal point separator and thousand separators. It should also provide information about how the digits are grouped together in the numbers and in currency. Apart from this, the date and time formats may also be different in different languages and regions. Let's take few examples. The two cards here show the number, currency and date times format represented generally in US and Canada regions. EN-US is for USA while EN-CA is for Canada. Both of them are English-speaking countries. The decimal point character used by these two locales is also same, which is dot. The thousand separator is also same,
and the currency symbol is also same. But as we can see here, the date and time formats are actually different. In US, the date is represented in month followed by day followed by year format, while Canada uses year followed by month followed by date. The separator which separates different components of date are also different in these two cards. Now let's have a look at another two cards. The third card is for Great Britain, while the fourth card is for India. The currency symbols here are different. Great Britain uses pound symbol while Indian locale uses Indian rupee symbol. Although thousand separator and decimal point separators are represented by same characters, the grouping of digits is not same. The same number 100k is represented differently on these two cards. Now let's open two more cards. The first card from the third column is how the same information is represented in German region, while the second card in third column is how the information is represented in Netherlands region. On both cards, comma is used as a decimal point separator, while dot is used as a thousand separator. This is different from all the previous cards. You might also have noticed that the currency symbol on the German card and currency symbol on Netherlands card, they are same, but the placement is actually different. The currency symbol is placed after the number on German card, while the currency symbol is placed before the number on Netherlands card. There are also three other cards which shows how the same information is represented in Japanese, Thai and Chinese locale. This locale information is passed to string operations by using culture info object. The culture info object combines all regional settings together into one object. The settings include language, number formats, date time formats, currency symbols, etc. There are three different kinds of culture info objects that are used very frequently. The first one is invariant culture. This means that both language and region is not specified. If invariant culture is used, then C# will use English as a language. For all the other settings, it will apply the defaults. Another way for passing culture info object is neutral culture. In case of invariant culture, we don't specify both language as well as region. But in case of neutral culture, we can specify the language explicitly. We don't need to specify the region. Finally, we can specify culture explicitly by specifying both language as well as region. We can specify the culture names like EN-US, EN-GB, or EN-IN. These culture names are specified in ISO format. First two letters are for language and then hyphen followed by few more letters specifying the region. For example, when we specify EN-US as culture name, then EN is for English language and US is for the region United States. Similarly, when we specify EN-IN, then EN is for English and IN is for India. This culture info object is basically an instance of culture info class, and this class is part of system.globalization namespace. So if we want to use culture info class, we should have a using statement to import system.globalization namespace. The code snippet here shows an example of how the culture info class can be instantiated and how it can be used for comparing two strings. Here we have used string.compare method. When we start execution of a program, it basically loads the default settings from the computer on which it is running, and all those settings are loaded as current culture of the program. We can also use that current culture object for performing string operations. I think we have enough information now about the cultures. So let's open Visual Studio and let's try to perform some culture-specific string operations. Now let's write a program to compare the strings. Let's take name as input and let's check if this name is equal to John using equality operator. This time we are hardcoding the value to be compared. If this condition is true, then display some message. After this if block, add another if block to check if this value is not equal to John. If it is not equal to John, then also display some message. And after this second if block, let's add another if block. This time we can use equals method to check if the input string is equal to the text John. All these three methods are comparing the input value with a hard-coded text. By default, it is ordinal comparison and it is case sensitive. So if I enter input John with lowercase j, then the second if block will display a message saying that I have not entered the expected name. Now let's try to convert this program to perform case insensitive comparison. For that, let's remove the first two if blocks and we can just use equals method. We can pass an additional parameter here in the equals method telling C# to ignore the case. And the parameter that we are going to pass is an enum value, string comparison dot ordinal ignore case. So the comparison is still ordinal, but the casing of letters is ignored. Let's run the program again and try to input the text John with lowercase j. Now even if the casing of letters is different, the program will correctly display the message that we have entered the expected input. Okay, let's write another program to sort the strings using ordinal comparison. Here we can declare a string array which contains 3 strings, and then we can call array.sort method, which takes 2 parameters. The first parameter is basically the array that we want to sort, and the second parameter is basically a value from enum string comparer. We can specify this second value to use ordinal comparison. Let's run the program and we can see the sorted output. So we have seen how to sort the array which contains multiple strings. Now let's move on to the next example. Let's see how to use linguistic comparison. Let's declare 2 strings. This time we are going to use string.compare method. The string.compare method returns an integer value that indicates relative position of the strings in the sort order. If the returned value is less than 0, then the first string precedes the second one. And if the returned value is greater than 0, then the first string follows the second one in the sort order. On the other hand, if the returned value is exactly 0, then the 2 strings share the same position in the sort order. So based on this information, we will try to display a message telling the relative sort order of these 2 strings. Because we want to perform linguistic comparison, let's create a culture info object. Here we are using new operator followed by the class name culture info. And then inside the parenthesis, we can specify a string literal specifying the culture name, in this case en-us. For using culture info class, we also need to add a using statement. So let's add using system.globalization at the top of the program. Now let's use this culture info object for comparison. For that, we need to use overload from string compare, which takes 4 parameters as input. The first 2 parameters are basically 2 strings that we want to compare. And then the third parameter is basically a culture info object. So we can pass the culture info object that we have created. The fourth parameter is a value from enum compare options. This value is passed to customize the comparisons further, but we are currently not interested in it, so let's pass none. Then we can add multiple if conditions to display information about sort order positions of these 2 string values. Okay, our program is ready. Let's run the program and we can see that the output says first string is less than the second string. This means that if we use en-us culture, the first string will precede the second string in the sort order. Always remember that these linguistic comparisons are platform dependent. They may produce different results if we run this same program on different operating system. Okay, let's move on. As we have seen, there are various operations that can be performed on string variables. All these operations have been coded in such a way that they can produce the results efficiently. But we need to understand one thing. Strings are immutable. Now the word immutable is new. What does this mean? Let's say we declare a string variable and initialize it with some value. Let's say John. This will create an object on the heap which contains this value John. Later in the program, let's say we want to modify this value. Let's say we want to append the last name. In this case, instead of modifying the current object, a new object will be created on the heap and the reference on the stack will be changed. It will point to the new object. So when any modification happens on the string class does not modify existing object. Instead, it creates new object, and that's why string types are immutable. Now why are we talking about this behavior? Because let's say your program wants to perform many operations on a given string. In that case, every operation would result in creation of new object on the heap. So every step would require additional time to create new object on the heap and then changing the reference on the stack to point to the new object. We can certainly make this operation more efficient by avoiding creation of new object every time. But how? By using string builder class. String builder class is mutable. After we perform any operation on string builder instance, it modifies the current object rather than creating new object on the heap. This code snippet shows how the string builder class can be used. String builder class is part of system.text namespace. So we need to add a using statement to import that namespace. Then the code uses new keyword to instantiate the string builder class. The syntax is variable name followed by assignment operator followed by new keyword, which is followed by class name string builder. And then after the class name, inside parenthesis, we can specify initial value that we want to assign to this string builder instance. The string builder class provides various methods which can be used for performing string operations. Here, in this code snippet, we have used two methods, append line and append. Append line adds a new line character to the string, while append method takes a string value as a parameter, and this parameter value is then appended to the value of string builder. Once all the intended operations are done, we can get the results into string variable by calling toString method on the string builder instance. Now, let's go back to Visual Studio. Let's write a program to reverse the string. We already have printed a given string in the reversed order. The logic is going to be similar, but this time we want string reversal to be done before displaying the output. This means we will need to iterate over all the characters in the reverse order and then append the characters to a new string variable. The new string variable can then be used to display the output. But we already know that performing too many modifications on a string type variable is not efficient. So instead of using string variable, we will use string builder type for the target variable. Let's begin our program. Let's take a string as input and then run the loop from last character of the string till the first character. Until the index is greater than or equal to 0, we want to continue this loop. And then inside the while block, we can take current character pointed by the loop variable index. This current character can then be appended to the string builder variable by using append method. This modification operation is not creating new object on the heap. It is modifying the existing string builder object. After performing this append operation, decrement the index variable by 1. After all the iterations are done, we can take the string builder value into a string variable. For that, we can call .toString method on the string builder variable. This string variable can then be used to display the outcome. Let's run the program. Let's try to input any random string and our program prints that same string in the reversed order. Okay, that concludes this section. I hope you find these code examples helpful. Let's move on. Let's move on to the last section of this chapter. These are some exercises that you can try on your own. In the first exercise, you can ask user to provide a string input and then display the counts of vowels and consonants from that string. In the second exercise, ask user to input a sentence and then display the count of words in that particular sentence. In the third exercise, ask user to provide as many names as user wants. In single input, the names should be separated by comma. Then split that string into multiple so that each string contains a single name. Then sort that collection of names and then display it. In the fourth exercise, write a program to input a string. That string may contain all the unique characters or it may contain some duplicate characters. Modify that string in such a way that string contains only unique characters. Remove all the duplicate occurrences of all the characters so that end result should not contain any duplicate character in the string, and then display that outcome. Alright guys, that's it from this chapter. In this chapter, we are going to begin our discussion with arithmetic operators. And after that, we will discuss about interesting concepts like arithmetic overflow and divide by zero situations. We will also have a brief introduction to the class system.math. This class provides constants and methods which can be used in many mathematical operations. Then in the last part, we will discuss about bitwise and shift operators. I hope you watch this video till the end because, like previous chapters, there will be some exercises for you at the end. You can try those exercises on your own to make sure that you have grasped all the contents from this chapter. Let's get started. This slide shows multiple arithmetic operators. We already have discussed about these operators in previous chapters. The plus sign is addition operator. The minus sign is subtraction operator. The asterisk is for performing multiplication, while forward slash is for performing division. Now let's talk about the final operator, the remainder operator. The forward slash is the division operator. It returns the quotient from the division. But what if we want to know the remainder from the division? In that case, we can use this remainder operator. This operator is represented by the percentage sign. Sometimes it is also called as modulus operator. All these operators needs two operands to work on. And that's why these operators are called as binary arithmetic operators. These operators do not modify the value of their operands. They read the values from the operands, perform the operation, and then return the result. This returned result can be then assigned to a variable.
or alternatively, if this expression is nested inside another expression, then the result of the nested expression is used to evaluate the subsequent portions from the expression. This new slide shows a code example. Here, two integer variables have been declared. They have been initialized with some values. The remaining lines from the code snippet shows how the arithmetic operators can be used. In this code snippet, we are using only variables as operands of arithmetic operators. Instead of variables, we can also specify numeric literals as operands of these arithmetic operators. So for example, instead of using a plus b, we can also use 5 plus 10. Also, in this code snippet, we have used only integer data type. We can rather use any numeric type with arithmetic operators. So instead of integers, we can use long or decimal or double as the data types. The last line from this code snippet explains how multiple operators can be combined to form a complex expression. Now it is time for one interesting fact. I told you that we can use arithmetic operators with numeric data types, but we can also use arithmetic operators with char type variables. Can you guess why? Because character type values are internally integers. So if we apply arithmetic operators on character variables, then the operator will perform arithmetic operations on numeric values of those characters, and then it will return a result which is of integer type. Okay, let's move on. This slide shows another set of operators. The first operator in this list is postfix increment operator. We already have used this postfix increment operator when we were discussing about loops and jumps in chapter 6. This operator is represented by 2 plus signs after the operand. It increases the value of its operand by 1. Similar to this, there is another operator, prefix increment operator. It is represented by 2 plus signs before its operand, and it also increases the value of its operand by 1. There is one difference between postfix and prefix operators. The postfix increment operation is performed after executing the line of code which contains that operator. On the other hand, prefix increment operation is performed before executing the line of code which contains prefix operator. Similar to these increment operators, there are also decrement operators. The postfix decrement operator is represented by 2 minus signs after its operand, while prefix decrement operator is represented by 2 minus signs before its operand. Both of these operators decrease the value of their operands by 1. All of these 4 operators are categorized as unary operators. This is because these operators work on single operand. Also, unlike binary arithmetic operators, these unary operators modify the values of their operands. Let's have a look at the code snippet shown here. The variable is initialized with value 3. The second line is simple console.writeLine statement which displays the value of variable I. Hence, the output is 3 in this particular case. Then on the next line, there is another console.writeLine. This time, the parameter to this method is a variable I, and there is a postfix increment operator applied to it. In this case, the console.writeLine will print the value of I, which is 3, and then it would increase the value of I by 1. So, on the immediate next line, if we just print the value of I, it should display 4. I hope this example helps in clarifying how the postfix increment operator works. Now let's have a look at prefix increment operator. The next 2 lines of code shows how the prefix increment operator works. There is one console.writeLine to print the value of I, but this time I has a prefix increment operator applied. As it is a prefix increment operator, the increment operation will happen first, and then the incremented value will be passed to console.writeLine. That's why the output will be 5 in this case. Did you notice the difference? In case of postfix increment operator, the console.writeLine was executed before applying the increment operation. On the other hand, in case of prefix increment operation, the increment operation happened before executing the console.writeLine. I hope this code example helps in understanding how the prefix and postfix increment operations work. On the subsequent lines, the usage of postfix and prefix decrement operators are shown. The same explanation applies to the decrement operators shown in this code snippet. On the next line, postfix decrement operator is used. So, console.writeLine would print the current value of I, and then the decrement operation would happen. Similarly, on the last 2 lines, prefix decrement operator is used. So in that case, the decrement would happen first and then the decremented value will be passed to console.writeLine. I hope you are following me. If you find these prefix and postfix operators confusing, do not worry at all. You can choose to avoid them while writing the code. You can simply use binary plus operator to increase value of any variable by 1, and it is perfectly fine. I brought these unary operators for discussion in this chapter because, in my opinion, it is better to know how these operators work. Knowing these operators would certainly help you in understanding the code that uses these operators. Okay, let's move on. There are two more unary operators, unary plus and unary minus operator. The unary plus operator returns the value of its operand as it is. On the other hand, unary minus operator returns the numeric negation of the value of its operand. So unary plus operator is equivalent to multiplying a variable by 1. On the other hand, using unary minus operator is equivalent to multiplying a variable by -1. As shown in this code snippet, if unary plus is applied to numeric literal 4, it would just return 4. But on the other hand, if unary minus operator is applied to value 4, then it would return -4. If two unary minus operators are applied as shown on the third line, then the innermost operator would return -4, and then this -4 value is used by the outer unary minus operator, and thus this nested expression would return the value 4. Note that these operators do not change the value of their operands, they return the changed values. So till now, we have covered all the important arithmetic operators, binary arithmetic operators as well as unary arithmetic operators. So let's move on. We already know that a single equal to sign is used as assignment operator. This operator can be used to assign some value to some variable. We have used assignment operator many times in previous chapters. This slide shows two statements in every row. The statements which are shown on the left side are the regular assignments, while the statements which are shown on the right hand side are the compound assignment statements. Each statement on the left hand side is equivalent to the corresponding expression shown on the right hand side. Let's take example. The first left hand side expression is a mathematical expression a plus b, and its result is assigned to variable a. This is how it is done using regular assignment operator. On the other hand, on right hand side, the compound assignment is used. The syntax for compound assignment is operand followed by addition operator followed by assignment operator equal to sign followed by another operand. This compound assignment means that perform the addition of a and b and assign the result to variable a. Both these statements, regular assignment statement and compound assignment statements, are equivalent. There is only one difference between the regular assignment statement and its corresponding compound assignment statement. The left operand is used twice in regular assignment statement. So the left operand is also evaluated twice. In case of compound assignment statement, the left operand is used only once. This means that it will also be evaluated only once. This behavior gives the compound assignment statement a little edge over the regular statements. Okay, let's move on. Till now, we have discussed all the arithmetic operators. I also have said that all those operators can be combined together to form a complex expression. This code snippet shows a mathematical expression. This expression uses many operators. The important question here is how this expression will be evaluated. What is the order of evaluation of the operators in this complex expression? For knowing the answer, we should know more about the operator precedence. This slide shows the order in which operators are evaluated. If an expression contains postfix operators, they are evaluated first. After that, if the expression contains prefix operators, then they are evaluated. After prefix operators, the multiplicative operators are evaluated if they are present in the expression. Multiplicative operators include multiplication, division, and remainder operators. These three operators have same precedence. And finally, if the expression contains additive operators, they are evaluated. Additive operators include addition and subtraction. The code snippet here shows a complex expression which contains many operators. Sometimes, if the expression contains many variables and many operators, then it may become hard to understand that expression. So, it may be better idea to use parentheses in the expression. Parentheses can be used to change the default order of precedence. The expression inside innermost parentheses are evaluated first. In this example, as written in the comment, the two parentheses
which contains modulus operators, are evaluated together. After that, all the additive operators are evaluated as they are inside the parenthesis. And lastly, the multiplication is performed to arrive to the result. If you think that the complex expressions are hard to understand and they are not readable, then of course you have option to break down the complex expression into multiple simpler and smaller expressions. Okay, now let's move to the next important thing. We have seen that the operator precedence levels can contain more than one operators at a given level. And when any expression contains multiple operators from a given level, they will have the same operator precedence. In that case, the operators are evaluated based on operator associativity. Let's see what operator associativity means. As already stated, if an expression contains multiple operators which have same operator precedence, then operator associativity determines the order in which those operators are evaluated. There are two types of operator associativity. Some operators are left associative while some are right associative. All the binary arithmetic operators are left associative. It means that they will be evaluated from left to right. For example, let's consider this expression. It contains only two operators, addition operator and subtraction operator. Both of those operators have same operator precedence. As we have said, binary arithmetic operators are left associative, and that's why this expression is equivalent to the expression shown on the right side. The right side expression calculates the addition first and then it performs the subtraction, and it is because those two operators appear in that order from left to right. On the second row, there is another expression which contains two assignment operators. The expression is A equal to B equal to C. As the assignment operator is right associative, B equal to C would be evaluated first, and then the remaining part of the expression is evaluated. I hope the concept of operator associativity is clear now. Let's move on to the next concept. Regardless of operator precedence, the operands are evaluated from left to right. This table displays some sample expressions in the left column. The right column in the table shows the order in which operands would be evaluated. As you can see, the order of evaluation is from left to right. For most of the rows, all the operands are evaluated before the operators. But in some cases, like in third and fourth row, some operands are evaluated and then some operators are evaluated and then again some remaining operands are evaluated. This is because sometimes runtime dynamically decides whether to evaluate further operands or not. To summarize, we have discussed everything about arithmetic operators. We also have discussed about operands and assignments. Let's move on. Before explaining next concept, let's have a look at exercise from chapter 5. This slide shows those exercises. The third exercise in particular was special. The problem statement says that program should take an integer value as input, and then this input integer value should be added to integer.maxValue. After that, we should display the result. In this problem statement, integer.maxValue is a constant provided by integer type. This is the maximum value that integer type variable can support. At the first glance, exercise seems to be fairly simple. We already have seen how to input a number. So let's exclude that part from our today's discussion. The crux of this problem statement is to understand what happens when we add any number to integer.maxValue. In this code snippet, we have declared a variable x, which is assigned to integer.maxValue. And then there are two console.write lines. The first console.write line displays the value of x, which is integer.maxValue. And then the second console.write line displays the result, which is generated after adding 1 to integer.maxValue. The commented area also shows the outputs that I got after running this code. As we can see there, the result of addition is negative. We know that integer.maxValue is a positive number. So how can be the result of adding 1 to a positive number is negative? How is this possible? Let's try to understand answer to this question. This horizontal line shows the finite range of integer values. When the result of any expression is outside the maximum allowed value, then the result is truncated by discarding any high order bits that don't fit in the destination type. And because of this behavior, when we tried to add 1 to integer.maxValue, the operation actually returned integer.minValue. This situation and the behavior is called as arithmetic overflow. In a nutshell, every data type allows only finite set of values, and when the resulting value from an expression does not fit that range, then arithmetic overflow happens. The behavior of this overflow depends on the data types involved. The code snippet that we have seen on the previous slide shows the behavior in case of integer type. For double values, arithmetic overflow returns a special constant, double.infinity. This code snippet shows an example. Here, double.max value is multiplied by a number, and this expression resulted into arithmetic overflow. If we print the value of the result, it shows infinity on the console. On the other hand, if an expression contains decimal type variables, and if that expression is resulting into arithmetic overflow, then the decimal type actually throws overflow exception. An exception is a runtime error. We have not seen what an exception is, so for now, we will not go into further details. Okay, now the other important thing. When a number is divided by 0, the result is non-deterministic. In C#, this is also a case of arithmetic overflow. And that's why, in this case as well, the behavior depends on the data type of the operands. The code snippet here shows some example of division by 0. When an integer type is involved and the divisor is constant and it is 0, then it is known at compile time, and that's why it would result in compile time error. If the divisor is not known at the compile time, and if while running the program the divisor becomes 0, then that particular line of code may throw divide by 0 exception. Next, when a double type is involved in a division by 0 operation, the result is infinity. Another interesting thing is, when a double value 0 is divided by 0, then the result of operation is NaN, which means not a number. Okay, this information is enough for understanding what is arithmetic overflow. Another important concept in case of arithmetic operations is rounding. Rounding is basically to replace a number with simpler and shorter number. The table given here shows various forms of rounding a number. The number can be rounded to its nearest integer value. Or if a number contains many decimal places, then it can also be rounded to use, let's say, only 2 decimal places. Otherwise, if a number is very big, then sometimes it is also rounded to use only few of the most significant digits. For example, instead of 23,220, we can just use 23,200. In programming, it is almost impossible to avoid rounding while performing many mathematical calculations. The rounding may occur due to how the mathematical operations are performed and how the floating point numbers are represented in the computer systems. The code snippet here shows 2 examples. Double value 0.1 is multiplied by 3, and then the code checks if the result is equal to 0.3. Ideally, it should be, but the equality check here actually returns false. Instead of double, if we use decimal data type here, the same operation would work as expected, meaning it would display true on the console. Why? Because decimal data type has more precision. The more the number of bits taken by a floating point data type, the more is the precision. In the second example, we have divided 1 by 3, and then the result is multiplied by 3 again. Ideally, the end result of these 2 operations should be 1. But interestingly, d is not exactly equal to 1, but it is very closer to the value 1. So, as I was saying earlier, it is sometimes impossible to avoid the rounding errors. We should always be very cautious about the precision that we need while calculating something. And for that, we should also be very cautious about deciding the data types to ensure that we get the required level of precision. Let's move on to the next topic. Let's have a quick introduction to system.math class. This class provides multiple constants and methods for performing many mathematical operations. Some of those methods and constants are listed here. It provides constant pi, which can be used in many mathematical operations. It also provides a method abs to find the absolute value of a given number. It also provides methods to find max and min from a given pair of numbers. There is also one interesting method, divrem. This method is very helpful if we want to know both quotient and the remainder from a division operation. Then there are also multiple methods for calculating logarithms. There is also a method to apply rounding to a given number. There are also some other methods which can be used to apply rounding to decimal point numbers. For example, there is a method floor which helps to calculate the floor of a number. The floor of a number is basically the largest integer value which is smaller than or equal to the given number with decimal point. For example, let's say the given number is 9.8, then the floor of that number is 9. Then there is another method to calculate ceiling of a number. The ceiling of any decimal point number is basically the smallest integer which is greater than or equal to the given number. For example, if the given number is 9.8, then the ceiling of that number is 10. There are also many other methods that are not listed here. I would suggest you to check the documentation for more details. Okay, this concludes our first section. Now, let's open Visual Studio and let's try to write some code.
Let's try to write a basic calculator. A calculator allows you to enter the first number. After the first input, you can select the operation that you want to perform, and after that you can enter the second number. An operation will be performed on those two numbers and the result will be calculated. After that result is displayed on the screen, we can again select the operation that we want to perform and again enter the next number. This time, the selected operation will be performed on the previous calculated result and the next input number. We will try to simulate this behavior in our console application. We will ask for input number and then inside the loop, we will ask for operator and next number. In every iteration, we will calculate a result and then that result will be used as a number in next iteration. For now, let's say we want to keep this loop running for 10 iterations. So let's add a code which asks for input and then convert the input string into integer. Now let's add a for loop which runs from I equal to 0 till I is less than 10. Inside the body of this loop, we can ask for inputting the operation that user wants to perform. So for that, we will display the allowed operations by using console.write, and then after that, we expect user to press any single character. Although we expect a single character from the console input, I will use console.readline which accepts all the characters until user presses enter. So the data type of this choice variable will be string. Then we can ask for new input which is also a number. So now we have an operator and two numbers. So based on the input operator, we want to perform operation and that operation will also return the result. So let's use switch expression which uses choice as input and it can also return the outcome. This switch expression will contain 4 arms. If the choice variable is equal to plus character, then let's perform addition. If it is equal to minus, then let's perform subtraction. If the input operator is asterisk, then perform multiplication. And now the last permitted operation is division. But instead of specifying division operator explicitly, let's use discard symbol here. The discard arm will match to any input which does not match 3 previous arms. So if user enters any characters which does not match 3 previous arms, division operation will be performed. Ideally, we may want to write a stricter code. Ideally, our code should show an error if the input is not valid. But for the sake of this demo, let it be like this. Now, in the loop, let's display the calculated result and then add an empty console.writeLine to distinguish current iteration of loop from the next one. Now let's run the program. I enter 12 as first number and then plus operator as my choice of operation. Then if I enter 8 as the next number, the output is 12 plus 8 which is 20. Because of the for loop, it is again asking me to enter arithmetic operator. This time I enter minus and then I enter 9 as the next number. Surprisingly, it is showing 3 as the result, which in my opinion is wrong. Ideally, it should have performed 20 minus 9 and the result should have been 11. But I think it is performing 12 minus 9 and it is printing 3 as the result. So it seems something is wrong with our program. So let's come back to the code. And it seems that we have missed to assign the calculated result to first variable. Let's add it in our code so that in the next iteration, first variable will contain previous result. Now if we run the program again and provide the same inputs, we should not see any surprises. It seems the outputs are correct for addition, subtraction and multiplication. In every iteration, it is taking previous result as first number and then user can input the operation and the next number as input, and based on these 3 values, the arithmetic operations are performed. Now let's try to use division operator. It seems like our division operator is performing addition. Why? I think it is a copy-paste mistake. After copying the code, I forgot to change the arithmetic operator in the default case of switch expression. So let's come back to the code and change the operator here and now run the program again. All the operations should show the correct result. One interesting fact, If I enter any random set of characters instead of arithmetic operators, it would perform division operation in this case. It is because we have added division operation as a default case in the switch expression. Let's now take another code example. In this code example, let's take two integers as inputs and then perform the multiplication of those two integers and then display the result. Simple code, right? Do you think it would cause arithmetic overflow? Let's see. Let's try to run the program and let's try some random inputs. First, I will try very big number as input. And we can see that our application is broken. It is showing a runtime error. Currently, our application is running in the debug mode. And when an application is running in the debug mode, it goes back to the source code to show the line where the runtime error has happened. And that's why the control went back to Visual Studio and we can see now that an overflow exception has occurred. Why? Because the input number could not fit into integer type variable and that's why the overflow happened. Okay. Now we know that the first place where overflow can happen is type conversion. Let's run the application again. Let's try two big random numbers as inputs. We can see that the multiplication result is negative. Ideally, the result should have been positive as both the input numbers are positive. But in this case as well, the multiplication result was very big and it could not fit into integer type variable. So the high order bits were discarded and only last 32 bits were picked. And because the high order bits were discarded, the number became small and it became negative because the truncated result set the sign bit is equal to 1. I hope you find this code example helpful to understand the situations where overflow can happen. And as I said earlier, we should be very cautious about where overflow can happen and how to handle that overflow. We should also be very cautious about which data types we should use for calculations. Now, let's convert this same program to use division operation instead of multiplication. Will it cause any overflow? We already know that type conversion may cause overflow. So that is one point where arithmetic overflow can happen. Can division operation cause overflow? Well, if we divide a first variable by second, then the result of division is actually lesser than the first number. So I would say ideally, division operator should not cause any overflow. Let's try to run the program and let's try some random inputs. Like let's say first input is 1 and the second input is 3. Our program displays that the output of this division operation is 0. Why? It is because the result of division is getting converted into integer value. Integer value does not support number with decimal points. So the result is rounded automatically to the integer value. Let's come back to the source code and typecast the result of division to decimal type. Now if we run the program again, the program correctly displays the output of division. Let's modify this program to understand how rounding works. So let's add calls to math.floor and math.ceiling to calculate floor and ceiling of division result. We can also use math.round to round the result. Math.round supports multiple overloads. We can use overload which takes two parameters. The first parameter is the number that we want to round and the second parameter is a value from enum midpoint rounding. This enum provides multiple values. We will use two values, away from 0 and to 0. Away from 0 means while rounding the numbers, always prefer going away from 0. And to 0 means exactly opposite. While rounding the number, always prefer to go towards 0. Okay, these statements are ready. Finally, we can also round the division result to use only two decimal places. For that, we will use an overload of math.round which takes two parameters. The first parameter is the division result and the second parameter is basically the number of decimal places that we want in the rounded result. And that's why we will pass the division result as the first parameter and 2 as the second parameter. Let's run the application. Enter 22 as the first number and 6 as the second number. We can see that the actual division result is closer to 3.67. When this division result is rounded to use only two decimal places, the result shows 3.67. The floor of 3.67 is 3 and the ceiling is 4. When this division result is rounded away from 0, 3.67 is rounded to 4. On the other hand, while rounding towards the 0, 3.67 is rounded to 3. I hope this code example was helpful. Let's move on to the next section. Every integer value is internally represented by a 32-bit binary value. For example, 0 is represented in binary as shown here. Every bit is set to 0. For representing -1, all the 32 bits
should be set to 1 as shown in the second row. In fact, we can write a small code to display the binary representation of any integral value. For that, we can use convert.toString method. In this method, we can pass two parameters. The first parameter is basically the integer value, while the second parameter is the base of the system in which the number should be represented. The regular integral values support 10 digits from 0 to 9, and hence the base for regular integral values is 10. For binary, a bit can be either 1 or 0, and hence the base for a binary number is 2. So, while calling convert.toString, the second parameter value should be 2. This method call returns a string which contains binary representation of the number. One important point to note is the returned value does not contain leading zeros from the binary representation. Another interesting fact, we can initialize any integer variable by using binary literal. The binary representation should be prefixed with 0b prefix. For example, integer value y is initialized with binary literal. The value has a prefix 0b underscore, and after the underscore there is 1 followed by 3 zeros. From this value, the prefix 0b is ignored and the rest of the bits are converted to integer value. Also, in the binary literal, the bits are grouped together into group of 4, and every group of 4 bits is separated from the others by using underscores. Anyway, coming back to the main topic, why are we suddenly discussing about binaries? Because we are going to talk about bitwise and shift operators. These operators work on individual bits. These operators can be used only on integral numeric types. The integral numeric types are the numeric types which do not support numbers with decimal points. So, the types like long, int, short, unsigned int, unsigned long, etc. can be used with bitwise operators. We are going to have a look at 6 different types of bitwise operators. Let's begin with bitwise complement operator. This operator is represented by using tilde character. When any integral value is prefixed by complement operator, it returns bitwise complemented result. Every 1 bit from the operand gets converted to 0, and every 0 bit from the operand gets converted to 1 in the result. Next 2 operators are shift operators. We can shift all the bits to the left by using left shift operator. This operator is represented by 2 angle brackets pointing towards left. The syntax is integral value or a variable followed by the operator followed by the number which represents how many bits should be shifted. In this particular case, 3 bits would be shifted to the left. The left shifting discards the high order bits that are outside the range of result type, and it also sets the low order empty positions to 0. We can also shift the bits to the right by using right shift operator. It is represented by 2 angle brackets pointing towards the right. It also has similar syntax. Integral operand followed by the operator followed by a number. The number on the right hand side of the operator indicates how many bits should be shifted to the right. This right shifting discards the low order bits. The behavior of high order bits depends on the type. For unsigned types, the high order bits are always set to 0. For signed types, the value of most significant bit is used to populate high order empty positions. There are 3 more operators. They are called as logical bitwise operators. The first one is logical AND. It is a binary operator and it needs 2 integral values. It returns the result which contains bitwise logical AND of the bits from its operands. At any given position, if both of the operands have a bit which is set to 1, then the operation sets 1 in the result at that particular position. Otherwise, the resulting bit is set to 0. The logical XOR operator is also a binary operator. It needs 2 integral values. It returns the result which is bitwise logical XOR of the bits from its operands. If at any given position the bits from both operators are not matching, then the resulting bit is set to 1. Otherwise, the resulting bit is set to 0. And finally, the logical OR operator returns the result which is bitwise logical OR of the bits from its operands. So if at any given position, if any of the operand has a bit which is set to 1, then the result will contain 1 at that particular position. I know these operators may sound confusing, and for understanding them better, we can now switch to Visual Studio and then try to use those operators in the code. Let's write a program to apply bitwise complement operator. So let's take an integer input and assign it to a variable with name first. Then apply the bitwise complement operator to that variable, and then store the result in another variable. After this, let's add two console.writeLine statements to display the binary forms of input number and the result of bitwise complement operation. Okay, it seems the code is ready now. Let's run the program and enter 13 as input. The next two lines display the binary representation of input number 13 and its complemented value. Note that we have used convert.toString to get the binary representations of integer numbers. The output of that method does not contain leading 0 bits. And that's why our program is also not printing the leading 0 bits while representing the number 13. All those leading 0 bits have been complemented to 1 on the next line. Also, we can notice that all the positions where the number 13 had bits set to 1, all those bits have been changed to 0. I hope this code example helps to understand how the bitwise complement operator works. Let's try another code example. Let's write a code which reads two integers as input. Then it should ask user to choose a bitwise operation that user wants to perform. After that, the code should perform the selected bitwise operation on the input numbers and then display the result. So let's start coding by taking two integers as input, then add console.writeLine to display the instructions for the user. The instruction says that user can enter 1 for left shifting, 2 for right shifting, 3 for bitwise AND, 4 for bitwise XOR, and 5 for bitwise OR. After this, we can add code which reads the integer value from the console. This integer value represents the user's choice. Here as well, we can use this choice as input in the switch expression. The switch expression can contain multiple arms. Each arm should correspond to a valid input value from 1 to 5. The arm corresponding to every valid input will perform the respective bitwise operation. Here is the switch expression and the code inside it. In this switch expression, we are going to use a discard pattern for matching all the invalid inputs. And for all the invalid inputs, our switch expression will return value -1. I am highlighting this again that this code in the discard arm is not appropriate. Ideally, if the input is not valid, then the code should show the error message to the user and it should ask user to enter a valid input. But for the sake of this demo, we are not going to do that. We will just return -1 if the inputs are invalid. This switch expression would also return a value which is result of the bitwise operation. Let's keep that value in a result variable. And finally, let's add few console.writeLine statements to print the binary representations of first input number, second input number, and the result of bitwise operation. It seems our code is ready. So let's run the program. If we perform left shifting operation on input 8, and if we try to shift the bits by 2 positions, then we can see that 2 most significant bits should have been removed, and on the right hand side, there should be 2 0 bits appended in the result. Now let's use the same inputs and let's try to perform right shifting operation. Here we can see that the 2 rightmost bits have been removed. To understand what is happening with the high order bits, let's try to input the negative number now. Let's say we enter -10 as the first input and 2 as the second input. And let's say we select right shifting operation. In the result, we can see that last 2 bits have been removed and the leftmost bit is used to populate the additional 2 bits that are added on the left side. As we have seen in the theory part, the behavior of right shift depends on the data type. Because integer type is a signed type, whenever we perform right shifting on integer type, the value of the highest order bit is used while populating the extra bits that are inserted due to right shift operation. Let's run the program again and let's input -100 and -200 as inputs. After that, select the bitwise AND operation by entering 3. Here I have intentionally used negative numbers so that we can see all the 32 bits in the binary representations of input numbers. On the result line, we can see that at any given position, a bit in the result is set to 1 only if both the inputs had 1 at that particular bit position. Okay, let's run the program again. This time as well, enter the negative numbers -125 and -250 and select bitwise XOR operator. Here, A bit at a given position in the result is 1 only if the bit values in both the inputs at that particular position are not matching. If they are not matching, then the result contains 1 at that particular position. If the bit values are matching, then the result contains 0 at that position. And as we can see, the result actually contains lesser number of bits. It is because all the leading 1 bits have been converted to zeros, and our code ignores the leading 0 bits while displaying the binary representation. Okay, now let's run the program again, and this time enter any two numbers as inputs and select the last operation, the bitwise OR operation. In the result of this operation, a bit at any given position is set to 1 only if any of the two input bits at that particular position is 1. I hope that this code example was helpful to understand how bitwise operations work. Now, let's try another problem statement. Let's try to write a code which reads a number as input. Then we should count the number of 0 bits in that number and then display the count. This time, the count should also include the leading 0 bits. We have an option to use convert.toString to get the binary representation of the input number, and then we can loop over that string to count the number of 0 characters in it. Instead of that, we will use binary operators. Let me first explain the approach. We can start with a temp number which contains only a single bit which is set to 1, and that bit should be the rightmost bit. Then we can perform the logical AND operation of the input number and the temp number. If the value of the rightmost bit in the input number is 1, then the result of bitwise AND operation would not be 0. In that case, we should increase the counter. Otherwise, we should not change the counter value. After this, we should apply left shifting on the temp variable. We should shift the bits by 1 position and then keep doing these steps 32 times because integer contains 32 bits. But wait, using this approach, we are counting the number of bits which are set to 1, and our problem statements wants a solution to count the bits which are set to 0. What can we do now? We can just complement the input number by using bitwise complement operator. That way, all the 0 bits will be converted to 1 bits and all the 1 bits will be converted to 0. And then we can apply the logic to count the number of bits which are set to 1. So let's add a code to take a number as input. After that, declare a temp variable and set its value to 1. In integer value 1, only the rightmost bit is set to 1. All the other bits are set to 0, and that's why we are using that value. And then we can apply the bitwise complement operator to input number. We can store the result of this operation into the input variable itself. After this, we can add a for loop which runs from I equal to 0 until I is less than 32. Inside the body of this loop, perform bitwise logical AND of input and temp. If the result of this operation is not 0, then increment the counter. Then left shift the bits from the temp variable by 1 position and store the result of this operation in temp variable. Finally, after the loop, display the value of the counter. Now let's try to run the program. Enter value 16, which contains only 1 bit which is set to 1. So all the remaining 31 bits should be set to 0, and our program correctly prints that the count of 0 bits is equal to 31. Let's give another try and let's run the program again. This time, let's input 5. The output of our program says that there are 30 bits in this number which are set to 0. It is correct. This is because 5 is represented in binary as 101. It contains only 2 bits which are set to 1. So all the remaining 30 bits are set to 0. So it seems that our program is working as expected. I hope these code examples were helpful. Let's move on. Let's now move on to the final section of this chapter. This section shows exercises that you should try on your own. In the first exercise, take a number as input and then apply bitwise operators to count the number of bits which are set to 1. Finally, display the count. In the second exercise, read a number as input and then print true if the number is power of 3. A number is power of 3 if it is result of exponentiation with 3 as a base and some number n as exponent. For example, your program should display true for numbers 3, 9, 27, 81, etc. because they can be calculated by using power of 3. But the program should display false for numbers like 6, 42, 45, etc. In the third exercise, read a number as input and then use division operator and remainder operator to reverse the digits in that number. After that, display the result. In the fourth exercise, ask for two numbers as input. After that, ask user to input any arithmetic or bitwise operator as input. Then, apply the input operator on the two input numbers and display the result. You can use switch expression or if statements to calculate the results. You can also add iteration statements to keep the program running until user wants it to run. Alright guys, that's it from this chapter. We are going to begin our discussion with arrays. Specifically, we are going to discuss about what is an array and how arrays can be declared. We will also have a look at some interesting concepts like multidimensional arrays and jagged arrays. In the second part, we will discuss about collections. We will see how the collections are placed into various namespaces. Then, from each namespace, we will have a look at some commonly used collection types. Finally, we will have a coding session to demonstrate how arrays and collections can be used in the code. I hope you watch this chapter till the end. At the end, you will find some exercises that you can try on your own to ensure that you have grasped all the contents from this chapter. Let's get started. Before we begin, let's try to understand why do we need arrays and collections. Let's say we want to write a program. That program is supposed to take many numbers as input. Then we want to display the sorted numbers on the console. As we want to perform sorting on the numbers, it is pretty much clear that we want a numeric data type. Let's say we will use integer as the data type for holding the number. But according to problem statement, there can be many inputs. So, how to store many numbers? Should we declare many integer variables? And even before that, do we know what does the word many means here? Does it mean fixed quantity, which is known at the time of writing the code? Or it is not known beforehand and the program is supposed to ask user about how many inputs user wants to enter? If the count of inputs is not known, then it would be impossible to decide how many variables we need to declare. Even though the count of inputs is known and we can declare multiple variables, it may not be a wise idea to declare tens and hundreds of variables for the data which is supposed to be grouped together. Now, what is the best solution for this case? Many times our application needs to process the data which can be logically grouped together. Perhaps this logical grouping is required so as to perform same set of operations on the grouped values. We may want to get a list of all students from a given university to calculate their grades or CGPA. Or else, we may be working on a sports app where we want to get the list of all cricket players from a given team and we may want to show their top 3 performances. For such purposes, there are two options. We can either declare an array of a given type or we can declare a collection. While declaring arrays and collections, we need to specify the type and then the arrays and collection can hold multiple values of that specified type. There is one basic difference between arrays and collection types. While declaring arrays, we are required to specify the size of an array. The size of an array defines how many values it can hold. This size cannot be changed later. So let's say we declare an array initially to hold 10 elements and later in the program we decide that we want same array to hold 20 elements now. It is not possible. We will have to declare another array and then copy all the values from old array to the new array. On the other hand, collections are more dynamic. We don't need to specify the size of collection. They provide flexible ways to interact with the collections. I know this may not clarify the difference between arrays and collections. This is certainly not enough to understand how arrays are different from collections. So let's have a closer look at these types. Let's begin with arrays. Arrays can store multiple values of given type. Here is the syntax for declaring arrays. Left hand side starts with a type name followed by square brackets and followed by a variable name. The square brackets specified after the type name indicates that the given variable is an array. After variable name, there is assignment operator. On the right hand side of assignment operator, there is a new keyword followed by the type name and the square brackets. This time, the square bracket contains a number. This number basically determines the size of an array. As I told earlier, the size of an array needs to be specified while declaring an array variable. This size determines how many values it can store. Here we have specified 8 inside the square brackets. It means that this array can contain 8 integer values as shown in the diagram below. Once array size is specified, it cannot be changed. So here, if we want to store more than 8 elements in ARR variable, it's not possible. For that, we will have to create a new array using new keyword, and then we will have to specify the new size. But this would mean that the values from the older array would be gone. So we will have to repopulate the new array with the values. For accessing values from the array, we can use square brackets after the variable name. Inside those square brackets, an index must be specified. This index is sometimes called as subscript. Arrays are 0 indexed. It means that if array length is n, then the index starts with 0 and the last element's index is n-1. The first index and the last index are also sometimes called as lower bound and upper bound of an array. If while reading a value from array, we specify an index which does not fall between lower bound and upper bound, then an index out of bounds exception is thrown. Now let's come to the values. When an array is created, by default every element is initialized with the default value of the data type of each element. For example, if we declare an integer array, every element's value would be 0 by default. This is because 0 is the default value of integer type. On the other hand, if we declare a Boolean array, each value in that array would be false by default. Similarly, if I declare array of reference type, let's say string, then the array values would be null by default. In the memory, the values in an array are contiguous, meaning they share the borders with the neighboring elements. So, if an array is fully populated, then inserting a value is an expensive task, because for this kind of insert operation, we will need to right shift the subsequent values. This slide shows multiple ways to declare and initialize the arrays. Here, I have intentionally used integer data type in first 4 examples to demonstrate various ways to declare the same array variable. Although these examples are using integer data type, we can use any other data type with this syntax. The syntax on the first line is already discussed on the previous slide. Array 1 will contain zeros in all 5 locations. The second way creates the variable and initializes with the values. The values are specified within the curly brackets. In fact, there is also an alternative syntax. We can skip new operator and data type. The right hand side of assignment operator on this line contains only values inside the curly brackets. In addition to these 3 ways, we can also declare implicitly typed arrays. For that, we can use var keyword as shown here. On the right hand side of assignment operator, there is a new keyword and a pair of square brackets. Note that this statement does not contain any data type specified. The data type is implicitly derived from the element types. That's why array 4 is an integer array. On the other hand, the last array is actually a string array, although we have not explicitly specified the data type. As discussed earlier, we need to specify index inside the square brackets for accessing a value from given array. Elements from all these arrays can be accessed by using single index. This is equivalent to a queue in which multiple people are standing. You can identify one person by specifying the position of that person from the front of the queue or from the end of the queue. This type of arrays are called as single dimensional arrays. We need to specify a single index to read the value from them. An array can also have more than one dimension. Let's now discuss the simplest form of multidimensional array, which is a 2D array. A 2D array can be thought as a table which contains specified number of rows and columns. For example, let's say we want to hold 4 movies, and for each movie we want to have 2 reviews from 2 different reviewers. In that case, we can declare a 2-dimensional array, sometimes also called as 2D array. In that array, each row will correspond to a movie and each row will contain 2 reviews. This code snippet shows multiple ways in which 2-dimensional arrays can be defined. While declaring multidimensional arrays, we need to add additional commas inside square brackets as shown in this snippet. For example, first row in the code snippet is to declare an array which contains 4 rows and 2 columns. We have not initialized values in this array, so all the values will be initialized with the default value of integer type, which is 0. In the second example, we have initialized the values for 2D array. the values for the rightmost dimension would be specified inside the innermost curly brackets. Here, in our code example, the rightmost number is 2 and hence the innermost bracket contains 2 values. Finally, let's talk about how to iterate over two-dimensional arrays. Iterating over single-dimensional array is easy. We just need to use length property to iterate over single-dimensional array. For multi-dimensional arrays, we can use getLength method. This method can be invoked on instance of an array. It takes an integer value as a parameter. The parameter value should be a zero-based index of the dimension for which the length should be returned. For example, for knowing the length of first dimension, we can pass 0. For knowing the length of second dimension, we can pass 1, and so on. The code here has a nested iteration statement. The outer loop iterates over the rows, while the inner loop iterates over multiple values within a given single row. I would suggest you to try running this code in Visual Studio to see the output of this code. It would clarify how the nested loops are working. It would help in understanding how the values are stored in the arrays. As I was saying earlier, the two-dimensional arrays are simplest form of multi-dimensional arrays. Similar to two-dimensional arrays, we can specify arrays which contains multiple dimensions. This code snippet here shows some examples. The syntax used for declaration is very similar to the two-dimensional arrays. Instead of specifying just two numbers inside the square brackets, we can specify as many numbers as we want. For iterating over multidimensional arrays, we can use getLength method. This method will return the length of specified dimension. We already have seen the usage of getLength method on previous slide. Let's now discuss about another type of arrays, jagged arrays. The word jagged literally means spiky, something with sharp points. This name itself suggests that jagged arrays contains pointers. Jagged array is basically an array in which every element is an array. The lengths of individual arrays may not be equal. In other words, every value in jagged arrays is basically a reference to some other array. So, when you define a jagged array variable, all the values in the jagged array would be by default set to nulls. The code snippet here shows jagged array. In this case, every element in the jagged array is a single dimensional array. That's why we have used two pairs of square brackets while defining the variable. Also, note that we have specified the length of jagged array in first pair of square brackets on the right hand side. The individual element in jagged array needs to be initialized separately. Here, in this code snippet, we have used the simplest syntax to initialize individual arrays. As we can see, each array has different length. In this code example, each value in the jagged array is pointing to a single dimensional array. If required, we can also declare jagged arrays in which every item is pointing to multi-dimensional array. Let's now understand how the jagged arrays are different from multi-dimensional arrays. The first code snippet here shows a code which initializes a two-dimensional array. This array can be visualized as a 4x3 matrix as shown on the right hand side. Now, the second code snippet shows jagged arrays. We already have discussed this code on the previous slide. As you can see, every element is basically a reference to a single dimensional array. The first value from the jagged array points to a single dimensional array which contains 4 elements. The second value from the jagged array points to another single dimensional array which contains 3 elements. And the third item from the jagged array also points to another single dimensional array which contains 5 values. And lastly, the final item from jagged array also points to a single dimensional array which contains 2 values. This picture will help you to understand why these arrays are called as jagged arrays. It is because they are array of pointers. Jagged arrays are also sometimes called as array of arrays. We have seen how to iterate over multidimensional arrays and single dimensional arrays. Iterating over jagged arrays is a bit different. This code snippet shows 2 different ways. The first way is to use Foreach statement. In every iteration, the iteration variable will point to individual item from the jagged arrays. So, that means this iteration variable will point to another array. Then inside this outer Foreach statement, we can nest either single or multiple Foreach statements, depending on whether every individual item in jagged array is a single dimensional array or multi-dimensional array. In this code snippet, we are showing the example of jagged array, which is an array of single dimensional arrays. So we just need a single inner loop. The inner for each loop will give us the individual value from the single dimensional array. This is how Foreach can be used to iterate over jagged arrays. Other option is to use any other iteration statement. In this code snippet, we are showing the for statement. Using the for statement is also very easy. We can take two index variables. The outer for loop with variable I actually iterates over jagged arrays. The inner for loop iterates over every individual item from the jagged array. For accessing individual values, we need to specify two pairs of square brackets. The first pair of square brackets will contain an index to get a single dimensional array from the jagged array, while the second pair of square brackets use index j to get the individual value from that array. Similarly, if we define jagged array as array of multidimensional arrays, then second pair of brackets will contain multiple indices separated by comma. I hope you find this example helpful to understand how to iterate over jagged arrays. Before we move on, here are some final comments on the arrays. I mostly have used integer arrays for demonstrations, but we can use any built-in or custom type instead of int while declaring the arrays. For example, we can declare an array to contain multiple datetime objects. Or else we can also declare an array of strings. Or else we can also declare array of some custom type, let's say person. Another point is, array is a reference type. So when an array is created, the array object is created on the heap while its reference is stored on the stack. When we use any data type to declare an array, we can store values from that data type only. For example, in an integer array, we can store only integer values. We cannot store double or decimal values in that array. If we want to store values of multiple types in a single array, then we can declare array of objects. System.object is the base type for all types in .NET. Whether a given type is a built-in type or a custom type, it is directly or indirectly derived from system.object. It means that if we declare array of objects, we can store any value in it. Although syntactically it is allowed, I would not recommend it. I would say avoid using object arrays to ensure the type safety in your code. Jagged arrays and multidimensional arrays can be combined. For example, we can declare a jagged array, which is an array of 3D arrays. Finally, we can also declare a jagged array, which is array of jagged arrays. So instead of array of arrays, we can declare array of arrays of arrays. This nesting can go to any level, but practically, in most of the cases, you may not need any further nesting after 2 or 3 levels. Okay, this concludes theory part of arrays. Let's now move on to the collections. Till now we have seen arrays. Arrays are the most useful for creating and working with fixed number of strongly typed objects. Then what are collections? Collections provide more flexible ways to work with group of objects. Unlike arrays, collections provide easy way to grow and shrink the group of objects. Technically, collection type is a class which internally manages group of objects. We must declare instance of collection class before using it. Some collections allow accessing individual items by using index. On the other hand, there are some collection types which store individual items as a key value pair. So, while reading values from those collections, we need to specify the key of the object rather than specifying the index. So, for accessing individual item for such collections, we need to specify the key. The collections can be found in 4 different namespaces. System.collections is the basic namespace which contains classes like ArrayList and HashTable. Most of the classes in this namespace use object type for every individual item. So, while inserting the data is converted to system.object type. And while retrieving the data, we need to typecast the data back to its original type. We will shortly have a look at what does this mean. The second namespace is system.collections.generic. The classes from these namespace are generic classes. They take data type as a parameter. The uppercase T inside the angle brackets are for type parameters. These type parameters are useful to ensure that only one type of values are being added to the collection. List, stack, queues, dictionaries are some commonly used types from this namespace. There are 2 more namespaces. The namespace system.collections.concurrent contains some classes which provide efficient and thread-safe operations for accessing the collection items from multiple threads. We will try to cover these collections later when we talk about multithreading. The last namespace is system.collections.specialized, which contains some special types of collections like string-only collections, linked list, hybrid dictionaries, etc. We will try to cover the collections from this namespace in some future chapter. Let's discuss a type from system.collections namespace, ArrayList. An ArrayList represents array of objects whose size can be dynamically increased or decreased as required. A sample code is shown here. There are various methods to manage the group of objects represented by an ArrayList instance. Some of the methods which are used in this code snippet are add, which adds a value at the end of ArrayList; insert, which inserts a value at the specified index; remove at, which removes an object from the ArrayList from the given index position; and clear, which clears all the values from ArrayList. ArrayList can be accessed using any iteration statement. The code snippet shows usage of Foreach statement. There is one interesting thing here. We have added few integer items and then we have also added a string item to the same collection. ArrayList allows it. How does it allow this? Basically, it allows any value of system.object type. System.object is the base type for all built-in types and custom types, regardless of whether the type is a value type or a reference type. So, integers are also derived from system.object and string is also derived from system.object. We can add any value of any type to ArrayList because it accepts any value which can be converted to system.object. For a second, we may think how convenient it is. If we want to store values of multiple types in the same collection, then this type ArrayList may appear to be the right solution. But wait, there is a problem with this type. Can you guess what is the issue? The get operation on ArrayList will give you a value which is of type system.object. That means if ArrayList contains values of multiple data types, then every time we need to read the data and we need to typecast it to the appropriate type. This also means that code should always be aware of data types of item at a particular position. If the code makes any mistake by performing typecasting on a wrong value, then an exception is thrown. For example, this line in the code snippet tries to typecast the value at index 2 to the integer type. But at index 2 there is a string. That's why this line would raise an invalid cast exception at runtime. Practically, it may not be valid expectation from the program to know the data type of every individual item in the collection. And that's why we should be very careful while deciding whether we want to use ArrayList as the collection type. Many collection types in system.collections namespace deal with system.object. With all those types, there is one more issue: boxing and unboxing. Now what does this mean? This slide explains the concept of boxing and unboxing. Let's say we declare an int variable x and initialize it with a value 108. As int is a value type, the value 108 will be stored on the stack. Now, in the second step, let's say we assign this value to a variable of system.object type. The type system.object is a reference type. That means its value should be stored on the heap. So when we assign integer value to the object type variable, the integer value 108 will be moved to the heap and the stack would contain a reference to that particular object. This process of implicitly converting a value type to system.object is called as boxing. Boxing may also happen if the value type is getting converted to any interface type. When boxing happens, a new object is created on the heap and then the value from the value type is copied into the new object. Now, let's say in the third step, we typecast the object variable to the integer type as shown here. In this case, the value stored on the heap will be moved to the stack. This process of converting system.object or any reference type value to a value type is called as unboxing. While performing unboxing, the system first checks that the value from the heap can be converted to the target value type. If the conversion is possible, then the value is copied from object on the heap to the instance of value type variable. This boxing and unboxing is related to how value type is represented in the memory. Boxing and unboxing are computationally expensive processes and they may have performance impact on the code. Hence, it is better to avoid them. Now let's come back to ArrayList. There are two basic problems with ArrayList. If we want to use ArrayList to store value type items, then it would cause boxing and unboxing. As we have seen, boxing and unboxing may cause performance impact and hence it may not be a wise idea to store value types in ArrayList collection. Now, regardless of value types and reference types, there is another problem with ArrayList. While reading the items, we need to typecast the item to appropriate target type. This means that program should always know the appropriate type of the item that is being read. Even if we figure out some solution to this problem, it may be very error prone. It may not always be possible to know which item is coming next and hence it increases chances of exceptions. As I have mentioned earlier, all the collection types from system.collections namespace deal with system.object. So these two problems exist with all those collection types which are part of system.collections namespace. And because of this, we are not going to have a look at any other collection types from system.collections namespace. Let's now move on to the next namespace. Now let's have a look at collection types from system.collections.generic namespace. This namespace provides various types. All these types are generic. A generic type is a type which takes a data type as a parameter. This parameter is specified between the angle brackets. In these generic collection types, the data type parameter decides which values can be stored in the collection. For example, if we pass int as the data type, the collection can store only integer values. And if we pass string as the data type, the collection can store only strings. Integers will not be allowed in that case. So, generic collection types allow creating strongly typed collections. Adding data to collections or reading data will not require any heavy typecasting. Due to this, the code which uses generic collections is more performant than non-generic collections. Although this namespace contains many types, we are only going to have a look at few of them. The types that we are going to see in this chapter are list, hash set, key value pair, dictionary, stack, queues, and priority queues. Let's start our discussion with list type. The code snippet here shows how the list of integers can be defined. Some common methods are shown here. We have declared a number list variable. Note that here we have passed int inside the angle brackets, and hence this list allows only integer values. Then we have called add method to insert a few items to the list. We also declared another list variable. This time we have initialized all the values in that list variable inside the curly brackets. After this, we called addRange method. This addRange method takes another list as a parameter. The items from the list which is passed as a parameter are copied to the number list in this case. This would add all the items from another list to number list. Next, there are two important methods, remove_at and remove. The method remove_at needs integer parameter. This integer value should be the index which is present inside the list. It removes the item from that particular index. So if we pass value 2 to this remove_at method, it would remove third item from the list. On the other hand, remove method takes an item as a parameter and that item is removed from the list. So if we pass value 5, the remove method will remove value 5 from the list. We also have used another property, count. This property returns the count of all the items that are present in this list. For iterating over this collection type, we can use any iteration statement. Similar to arrays, we can read data from the list using indexers. We can specify the index inside the square brackets. Lists also have a zero-based index. So if list contains n items, first item will be present at index 0 and the last item will be present at index n-1. However, if we specify the index which does not exist in the list, then it would cause an exception. The last line in this code snippet calls clear method. This method call removes all the items from number list. So this list data structure is very similar to arrays. The only difference is the list can dynamically grow and shrink. As a consumer of that type, our program does not need to write any code for growing or shrinking the list. Everything is managed internally by the list class. We have seen only few methods from this class. I would suggest you to go to documentation and check the remaining methods from the list type. Now let's have a look at another type from system.collections.generic namespace, hash set. A hash set is an optimized collection of unordered, unique elements that provide fast lookups and high-performance set operations. This code snippet shows how to use a hash set. The code snippet first declares set A and initializes it with some value. While initializing, we can see that there is a duplicate value. Hash set ignores the duplicate values, and ultimately set A would contain only 4 unique values. There is another variable, set B, which is declared and initialized with some values. We can see that code snippet has usage of contains method, which returns true if the parameter value is existing in the set. Another method, isProperSubset, can also be used, which takes another set as a parameter and it returns a Boolean value. A set is a proper subset of another set only if all of its elements are present in the other subset as well. In this case, set A is not a proper subset of set B and hence this method would return false. Hash set also provide methods to calculate union and intersection of two sets. These methods can be called on an instance of hash set and they take another hash set as input parameter. Union with method calculates the union while intersect with method calculates the intersection of two sets. There are some comments in this code snippet. They show how the set A would look after completing union and intersection operations. There is another interesting method, except with. If we call this method on set A, it will return all the elements from set A which are not present in set B. In case of this code snippet, set A and set B contain same values by the time control reaches this except with call, and hence this call makes set A as an empty set. We can also use .count property to find how many values are present in a hash set, and we can also use add method to add the elements to the hash set. And finally, we can use any iteration statement to iterate over hash set. Again, this was a brief overview of this type. I would suggest you to check the documentation for more details. Let's now see what is a dictionary. This type of data structure is a bit different. In dictionary, every item is basically a key value pair, and that's why dictionary takes two type parameters. We need to pass the data type for key, and we also need to pass the data type for value as a parameters inside the angle brackets. Here in this code snippet, we have set the key type to be string and string array as the value type. Then the code snippet shows how to use add method. Add method is used to add a key value pair to the dictionary collection. In our case, key is a string, so we are passing lead1 as a string, and then as a value, we are passing two string values inside the string array. Similarly, on the second line, we are passing lead2 as the key, and then another two values are passed as a value in this particular key value pair. Note that dictionary requires keys to be unique. If we try to add same value again, then add method will throw an exception. Also, because this is a key value pair collection, if we know the key, then we can easily find the corresponding value by using indexer. That's the reason dictionaries are very popular and they are very commonly used for lookups. Here in this code snippet, we wanted to perform lookup using string value, and that's why we have declared the key type to be string. Then, the last lines show how to display all key value pairs present in the dictionary. Here we have used a Foreach statement. I have intentionally used key value pair type instead of var in the Foreach statement. We can see that the iteration variable item is of type key value pair, where key is of type string and the value is of type string array. These are the same types that we passed to the dictionary. Okay, this was the brief introduction to the dictionary type. Now let's have a look at another interesting type, stack. A stack is a last in, first out data structure. I am not going to explain what stack means here. We will just have a look at this code snippet which demonstrates how to use stack. This class is a generic class and it takes a type as a parameter. Here, in this code snippet, we have declared a stack of type string. So, we can add string values to the stack. Again, we could have passed any other built-in type or custom type as a type parameter. For example, in order to declare a numeric stack, we could have passed integer. Or else, we can also use any custom type and pass it inside the angle brackets while declaring a stack variable. The stack will only allow values from the type which was used while declaring the stack variable. The stack class provides push method to add the new items to the stack. Pick method returns the value which is present at the top of the stack. It does not remove the value from the stack. Pop method removes the value from the top and returns it. This code snippet also demonstrates how to iterate over items present in the stack. Now let's discuss briefly about the queue type. Queue is a first in, first out data structure. C# provides a generic class which takes type as a parameter. We have defined a queue of strings. There are two methods that are used in this code snippet, enqueue and dequeue. Enqueue method is to add a new element to the queue, while dequeue is to remove the element from the queue. There are also other methods to check if the queue is empty or to check the count of items in the queue. Please refer the documentation for knowing other methods and properties. We can also use any iteration statement to iterate over queue as shown here in this code snippet. Priority queue is the new type which was introduced in .NET 6. This is a special type of queue. It is a queue, so it is also a first in and first out type of data structure. Similar to queue type, it also supports enqueue and dequeue methods. There is one important difference. While enqueuing items, we need to specify the items and priority. Then while dequeuing, the highest priority item is returned first. While declaring, we need to pass two types to priority queue. So every item in the priority queue basically has two things, the actual value and the priority. And that's why priority queue takes two types as the parameter. The first type parameter determines the data type of actual value, while the second type parameter determines the data type of priority. Here we have passed two types, string and int. String is the type of value that we want to store in the priority queue, and basically every string value will have some integer priority assigned to it. When priority is a number, by default, the lowest number has the highest priority. So, when we dequeue the elements, item A will have the highest priority and item B will have the lowest priority. In this code snippet, we have not shown dequeue method. Its usage is similar to normal queue type. We don't need to pass priority. The queue will automatically determine the priority and it will return the next value. The last few lines in this code snippet demonstrates the try dequeue method. This method returns a Boolean value. It returns true if the item was dequeued successfully. The dequeued item and its priority will be returned as the out parameters. And as shown in this code snippet, for iterating over priority queue, we can use any iteration statement. Okay, this was the brief introduction to the priority queue. We have covered almost all the important types from system.collections.generic namespace. So, to summarize, we have seen what is arrays. We also have discussed about single dimensional arrays and multidimensional arrays. We also have seen examples of jagged arrays. After that, we have seen various collection types. Now it is time to open Visual Studio and then use these types in our code.
Let's try to write a program. This program should take 10 numbers as input. There can be duplicate numbers in this input. So our code should filter out the duplicates and should display only the unique numbers from the input. Let's use array for this solution. So first declare array of 10 elements and then we can add a loop which runs 10 times. In every iteration, the loop can ask for input number and then the input number can be converted to integer and this integer value can then be added to the array. Okay, input part is ready. Now the next plan is to read numbers from input array one by one and put it into another array if it is not repeated. So let's declare another array, output array. Its size should also be 10 because that's the maximum number of unique elements user can enter. Let's assume that the first number is a unique number and let's add it to output array. As we know, array length cannot be changed after its declaration. So in order to keep the count of unique numbers, let's declare another variable, unique numbers, and set it to 1. We have added first number in the output array because currently output array is empty. Starting from next number, what the program will do is, it will take a number from input array and then it will check if the number exists in the output array. Then let's write a for loop. Inside this for loop, let's read the number at index I from the input array. Let's call this number as current number. The idea is to check if this number already exists in the output array. If it doesn't exist, that means it is a unique number and hence it should be added to the output array. If the number already exists in the output array, then it should not be added to output again as it is a duplicate occurrence. So for this, let's add inner loop which runs from j equal to 0 until j is less than the value of unique numbers. If the number pointed by index j from the output array is equal to the current value from the input array, then it means that the number is duplicate. So we should break the loop. But while breaking the loop, we also need to convey the outer loop that this number was duplicate. For that, we can declare a Boolean variable. Let's add isDuplicate Boolean variable, initialize it with false, and when the duplicate element is found in the array, let's set isDuplicate value to true before breaking the loop. In the outer loop now, we can add a condition to check if isDuplicate value is equal to false. If it is equal to false, then we can add the current value to the output array. Okay, our core logic is ready. Now we just need to write another loop to display the contents of the output array. This loop will now run from index equal to 0 until index is less than the value of unique numbers variable. Our program is ready. Now let's try to run the program. I am providing any random numbers as inputs and we can see that the output correctly displays unique numbers from the input. The program can certainly be optimized further, but the intention here is to make sure that you understand how to use arrays. Now let's remove this code and let's try something interesting. We have declared array of 10 variables and we already know that the last element will be present at index 9. But for now, let's try to use index value 10 for reading a value from input array. And let's see what happens. Let's try to run the program and we can see that program is broken. We can see that the program is throwing index out of range exception. It happened because the index that we have specified for reading the value from the array is not between the lower bounds and upper bounds of the array. Okay, let's move on to the next sample. Let's see how the arrays can be resized. An array always has fixed size. So if we want to change the size, we will need to declare another array. So let's declare another array variable. The size of this new array should be 20. After this, we will have to add a loop to copy the values from the older array to the new array. Older array contains only 10 elements and hence we can run the loop from I equal to 0 until I is less than 10. We can make the loop condition dynamic by using length property of the input array as well. The length property returns the size of array. Okay, now inside this loop, assign the value from input array to the new array. After this for statement completes its execution, the new array will have all the values from the older array. But our array variable input ARR is still pointing to the smaller array. So let's assign the new array to the input ARR variable. By doing this, input ARR variable will point to the array which contains 20 elements. And that's how the array can be resized. Now we can print the length of input array at two places. First, we can show what was the length of input array before performing the resize operation, and then we can also add another statement to show the length of input array after resize operation was performed. If we run the program now, the program correctly prints that the size of input array was 10 before performing the resize operation and it was 20 after the resize was done. Okay, C# also has a class with name array. This class provides multiple methods to manipulate arrays. Let's have a look at some of those methods. This array class has a method called resize. This resize method does the same thing that we have done here. That method requires two parameters. The first parameter is the array that needs to be resized, and the second parameter is the new length of the array. The first parameter also has a ref keyword specified. We have not seen what this keyword means. In short, it is to make sure that the new array's value is stored in the input variable which is passed as a parameter. The array class also provides a Foreach method that can be used to iterate over the array. It takes an array as the first parameter and the second parameter is the action delegate. You can think of action delegate as a reference to a void method. This action delegate receives every individual element from the array as input. So we can just print that input value. If we run the program now, we can see that the Foreach method is able to display the contents of the input array. The array class also provides two other methods, sort and reverse. As the name suggests, sort method is to sort the input array. If we pass integer array, the numbers will be sorted in ascending order. And then there is this reverse method. This method is to reverse existing order. Note that here we are calling reverse method after the sort, and hence this method call will arrange the elements of array in the descending order. Reverse method does not sort elements in any order. It just reverses the current order of elements. So the last element becomes the first one and the first element becomes the last one. Now, if we run the program, we can see that the program correctly prints the sorted output and the reversed output. Okay, I hope these examples help you to understand how to use arrays. Let's move on. Now again, let's try to write the same program which takes 10 numbers as input and it displays the unique numbers from the input. This time, we are going to use list generic type. So let's declare a list variable and pass integer as the data type. This variable input list should now be populated with 10 numbers. For that, we will run a loop 10 times. In each iteration, it will ask for input. The input will be converted to integer value, and then this integer value can be added to the list by calling add method. While calling add method, the integer value should be passed as a parameter. After completing 10 iterations, this list should be populated with 10 inputs. If you remember, while solving this problem statement using arrays, we took another array variable. This time, we are not going to declare any other list variable. Instead of that, we will run a loop on this particular list and then we will use remove at method to remove the duplicate occurrences of a number. So let's add a loop which runs from I equal to 0 until I is less than 10 and then read the current value from the list which is pointed by index I. Now the idea is to check all the subsequent numbers from the list to see if there are any duplicate occurrences of the current number. So let's write another for loop which is nested and it starts from j equal to I plus 1 and it runs until j is less than 10. Now inside this inner loop we can add a condition to check if the value pointed by index j is equal to current value. If it is, then remove that item by calling remove@, method and passing j as the parameter. It seems our core logic is ready. Then we can use Foreach method to display the contents of the list. Do you think there is any problem with this code? Maybe there is no problem. So let's try to run the program. Provide 10 numbers as input and after 10th input, we can see that the program has thrown the exception. It is saying that the index j is out of range. That means the list contains lesser elements than the current value of index j. Why this exception is thrown? It happened because we are removing the elements. Every time remove@ method is called, the count of items in the list is decreased. Let's say after removing first duplicate, the count of list will change from 10 to 9. If there are any further duplicates, then the size of the list will keep on shrinking. But the condition in our inner loop does not consider this fact. It is blindly asking loop to continue 10 times. So what can we do now? We can change the condition. Let's remove this hard-coded value 10 from the condition and then use list.count. So when duplicates are removed, list.count will give the updated value and thus j will never go out of bounds. Let's also change the condition in the outer loop and let's use list.count there as well. Now let's run the program again. We can provide 10 numbers as input and this time we can see that the program is working as expected. It is correctly printing the unique numbers from the input. Like array class, list class also provides sort and reverse methods. We can change the program to print the sorted output which will print the numbers in ascending order and then we can call the reverse method to reverse the order of elements. We can run the program again and we can see that the ascending and descending orders are correctly printed by the program. Let's come back to the code and let's try to change this program to implement string sorting. The problem statement is we need to ask multiple words as input. Those words can be provided as a part of same string input and those words should be separated by comma. So first, let's change our list variable and pass the string as the data type. This time, we want input to contain comma separated list of multiple words. So let's add a console.readline which will return us the input string which contains multiple words. After that, we can call split method and we can pass comma as the parameter. This split operation will return an array. It will contain multiple words that were entered by the user. This returned value, which is an array, can be converted to the list of string by calling toList method. This toList method is an extension method which is part of system.linkU namespace and hence a new using statement should be added to import that namespace. This project has implicit usings enabled, which by default imports system.linkU namespace, and hence I do not need to add the using statement in my code. But if you are using any previous version of .NET which does not support implicit using, or if you are using .NET 6 where implicit usings is disabled, then you might want to add that using statement. Okay, now we have the list of strings. We can add a validation now. This validation should stop the program if the input is invalid. So if the input list is null or if it does not contain any elements, then our program should display the error message, and after displaying the error message, we can add a return statement which stops the execution of the program. Note that return statement just returns the flow of execution from current method to its caller. In our case, we are writing this statement in the main method, and because of that, the program execution will stop. We will discuss about methods and return statements again in some future chapter when we discuss about methods. Okay, now we can keep rest of the code as it is. The sort method will use the default comparison logic to sort the list of strings, and then the Foreach method can display the contents of the list. Here, the action variable number can be changed to word, but it is not mandatory. As we are passing list of string as the input parameter to the Foreach method, the Foreach method can identify that this variable should be of string type.
So even if we do not rename this variable number to word, it would still work. But to have better readability, let's rename it. Now we can run the program and let's enter comma separated list of words. We can see the outcome of the program and it seems most of the words are sorted correctly except the first one. It is because the space character is being considered while sorting. As all other words contain leading space, they are promoted before the first input kite, which does not have the leading space. So let's come back to the program and let's change the code. We will have to trim the input words. So let's run the loop on list items and then trim the item in each iteration. Let's run the program again, provide some strings as input, and we can see that the sort order is correct now. Let's now move on to the hash set. Let's try to write the same program which takes 10 numbers as input and displays the unique numbers from the input. Let's declare a hash set variable and then pass integer as the type parameter. Now let's run a loop 10 times to ask for inputs. In each iteration, we can ask for input and then the input value can be converted to integer and then that integer value can be added to the hash set by using add method. Okay, our hash set is populated with all the inputs. If you remember correctly, hash set contains unordered unique elements. Even if we add duplicate elements, hash set will retain only unique occurrences. So we do not need to apply any additional logic to find the unique elements. We just need to iterate over hash set and display the items. Let's add a for each loop to iterate over hash set and display each item by using console.write as shown here. Let's run the program. Let's provide some inputs. And we can see that the program is correctly printing the unique values. So we have seen how to use list and hash sets. Let's now write the same program using the dictionary. The idea here is input number will be the key and the value will indicate how many times that input was repeated. So let's declare a dictionary variable like this, where the key type and the value type both are integers. Then write a loop which runs 10 times. Inside this loop, ask for input. Convert that input to the integer. Once we have the input integer, we can check if the dictionary already contains that number. Remember that input is the key in the dictionary. So for that, we will have to check if dictionary contains any key value pair where key is equal to this input. For that, we can use contains key method. This method returns true if the dictionary contains any item whose key matches to past value. So let's give a call to contains key method and pass input number as the parameter. If this key is found in the dictionary, then increase the occurrence count by 1. And if this input number is not found, then add a new key value pair to the dictionary. While adding, we can pass the input number as the first parameter, which becomes the key, and we can pass 1 as the second parameter. Here we are passing 1 to indicate that the input number has occurred exactly once. Okay, so the input part is ready. After this loop completes, we will have our dictionary populated with multiple key value pairs. The keys to all those records will be the input numbers, while the corresponding value will indicate number of occurrences of that input value. So basically, all the keys in our dictionary represent unique numbers from the input. So what we have to do? We just have to print all the keys on the console. Dictionary has a property dictionary.keys. It returns the collection which contains only keys of all the records present in that dictionary. So let's add a Foreach statement like this to print all the keys from the dictionary. It seems our program is ready. Let's run the program. We can provide some random inputs and then we can see that our program is correctly printing the unique values. Okay, let's move on. Now, let's see how stack can be used. Stack is a last in first out data structure. It basically returns the last element which was pushed to the stack. So this time we are going to use an interesting problem statement. The program is supposed to take a string as input. This input should contain only opening and closing parentheses. Then the program needs to check if the parentheses are balanced. An expression is balanced if both order and count of opening and closing parentheses match. So when a closing bracket is encountered, the previous character should always be an opening bracket. This is very common problem statement and it can be solved by using stack. So let's begin our code and let's take a string as input. Let's trim the input to remove
any leading or trailing spaces, and let's assume that the input contains only opening and closing brackets. Now let's declare a stack variable. This stack should contain items. Each item should be a character. So let's pass char as the type parameter. Now let's run a Foreach loop on the input string. In every iteration, check if the loop variable is opening bracket. If it is, then push it to the stack. If it is not the opening bracket and if it is a closing bracket, then call the pop method to get the latest item from the stack. The pop method call removes the item from the stack and it returns it. Let's assign the returned value to a variable. This popped item variable should be equal to opening bracket. If it is not, then we can break the loop and display that expression is not balanced. So outside the for loop, we need to convey somehow that the expression is not balanced. For that, let's declare a Boolean variable is balanced, which is by default set to true. Now in this if statement, let's set is balanced is equal to false before breaking the loop. Okay, it seems the core part of our solution is ready. Now after this loop, we need to check if the stack is empty. If the number of opening parentheses and closing parentheses are equal, then the stack will be empty. In addition to that, if isBalanced variable is true, then it means both the order and the count of opening and closing brackets are correct, and hence the program should display the output that the expression is balanced. In the else part, we can add code to display that the expression is not balanced. Let's run the program. Provide a balanced expression this time, and program correctly identifies that the expression is balanced. Now let's run the program again and provide only closing bracket as the input. Surprisingly, our program throws exception. The exception is invalid operation exception. Can you guess why this exception was thrown? This exception occurred because our stack was empty when pop method was trying to remove the element from the stack. So let's come back to the code and let's modify this condition to make sure that stack should not be empty when the closing bracket appears. Let's also add an else block which will execute if both the if conditions specified above evaluate to false. In that case, we can mark is balanced to false and break the loop. Now let's run the program again. We can see that program correctly works for single closing bracket. It correctly prints that the expression is not balanced. Now let's move on to priority queue. Let's write a simple program to demonstrate how to use priority queue. The program should ask for 10 tasks. For every task, user can input task name and its priority. All those tasks will be added to the priority queue. And then we can iterate over priority queue, and in each iteration, we can call dequeue method. This dequeue method call will remove the highest priority item from the queue and it will also return it. We can display the returned value on the console. So let's begin the code by declaring a priority queue variable where the first type parameter should be string and the second type parameter should be integer. Now let's add a loop which runs 10 times. In every iteration, ask for two inputs. The first input is a string and it is the task name, and second input is integer which is supposed to be priority. After we have these two inputs, let's add a condition to check that the task name is not null or empty string. If it is not, then add it to a priority queue by calling enqueue method. So when this loop is complete, we will have 10 inputs populated in the priority queue. After this, we can add a while statement. This loop will continue until the count of items in the priority queue is greater than 0. In every iteration, let's call dequeue method. This dequeue method removes the element, so it will also change the count of items in the priority queue. The output of dequeue method can be then displayed on the console. Our program is ready now. Let's run the program now. Provide some tasks and their respective priorities as input. After entering 10th task, we can see that the program is correctly printing the tasks based on their priorities. Priority queue itself is a very big topic, and I have used only this simple example to demonstrate how the priority queues should be used in the code. I hope you find all these code examples helpful. This concludes our coding section. Let's move on. Let's now move on to the final section of this chapter. This section shows the exercises that you can try on your own. In the first exercise, read many numbers as input. Then apply some sorting technique to them. You can apply any sorting technique that you know. After that, display the output.
Do not use array.sort or list.sort methods. In the second exercise, read a very long string which contains multiple sentences. Then display the count of how many times each word appears in that string. In the third exercise, take a string as input. This string should contain only parentheses, curly brackets, and square brackets. Then the code should check that the pairs and the orders of brackets are correct. In the fourth exercise, input many integers and then the code should find the third largest integer value. Try not to sort the collection and try to find an alternative solution. Alright guys, that's it from this chapter.
Thanks for watching. If you found this content helpful, like this video and subscribe to the channel. If you have any feedback or suggestions, please let me know via comments. Alright, see you in the next chapter. Namaste.